Naresh Kumar, please mute yourself.
Okay, let's go one by one. So I don't know the who have raised first, but his name indication is A267. So yes, what's your doubt?
Hello, sir.
Yeah, hi. What's your name?
Sir, my name is Aditya Vaidya.
Okay, hi Aditya. So what's your doubt?
Sir, can I say something?
Yeah, sure.
Sir, it will be great if you go through the first week's content in a short and crisp manner
Okay.
so that
Yeah,
we
sure.
can get
So I was also
a
thinking,
glimpse of
yeah,
it.
so that it would be good if you all of you mute yourself first thing. So I will go one by one with the summary. I want to show you. Let me mute yours all. So I want to show you something regarding the book. So let me open it. It is actually written like you can find the in a crisp way in a summarized form of the all lectures. I will say it is prepared. I think till week 6 you will find. Then the second portion is of calculus, and also the third is week 1 to 4, and calculus still remain to add. Oh, this is only week 1 to 4 it's showing. So it will be updated soon. We have a book till week 1 to 6, and then we have the calculus portion, and also the graph theory portion have written also. So if you go with the like if you go through the book, you will find the whatever you will see in the lecture video. Those all things in written as a key points, and uh, some with this with some example maybe different from the activity or even the class also, whatever sir have taught video lecture in the video lecture. So and you will find some exercise in that, maybe contain the practice assignment activity questions. But yeah, the thing is you will find a summarized form of the each week. Like if you say that this is about the function, type of function, when we'll say a function is injective, surjective, bijective. So all things you will find in a proper manner. So I will suggest you that going through the lecture is one part. If you are not getting in a proper understanding, if you want to go through a quick way, so also can go through by this book. So this book is still week 1 to 4. We have also completed 5 and 6. So you will get soon the updated book. And yeah, if you want to revise anything for the quiz exam, you can. I will suggest you. Yeah, the revision sessions are also used to happen, so those you can attend and also follow the books. That would be enough to revise the concept. So this is I want to tell you. This is one thing. So. So think as the TA session is also happening. So one thing I want to like the TA session is more for the you will say the doubts. So I have seen. Let me see how many of you have raised your hand. Okay, so
where can we access this book, sir?
in the portal it is. In any qualifier or term you can see it. And that you can access the book is in the supplementary content. The practice solution will be uploaded soon. I have told the operational team they will upload the practice solution of week 1. Okay, so I am looking 25's raised hand. So I will say, yeah, Aditya have suggested to go through the concept, so that I will do. But before that, if who have among the 25, so let me open with one by one. That who is here for only the doubts. So like I want like he wants to just resolve his doubt and leave can leave the session also. If such If someone is there, please let me know. Can unmute yourself. I will solve your doubt. Yeah.
Yes.
Yeah, Himanshu.
I have just passed class 11th. I
Okay.
am facing difficulties in understanding the functions part.
Okay.
I don't have a strong base on mathematics. So could you
Okay.
please give
Yeah.
an lecture on that?
Yeah. I will repeat. So your doubt is again a conceptual. Okay. So let me go. I think it's better to go with the concept wise and lecture wise. So let me start with that, and we'll take the doubts. You can someone have doubt some particular activity or practice in the last of the after finishing this week one content summary. Then we can take your doubts. I think it would be better.
Yeah, sir, that will be great.
Yeah. So let me go with in between. Let me mute to all of you. So in between, the thing is like when I will start, if you have doubt while in between, suppose some concepts I'm discussing. So there, if you have doubt, please let me know. If you are not getting that, also let me know. We'll repeat it again. Okay. Okay. So let me start with that. So
Excuse me, sir.
yes. Hi. What's your name?
Nikhil Kumar.
Yeah, Nikhil.
Sir, when week 2 content is added in portal?
Week 2 content probably today will add it.
Okay, sir.
Okay. So
Sir, good morning, sir.
good morning. What's your good name?
Sir, my name is Sandesh, sir.
Yeah. Hi, Sandesh.
Sir, I have a doubt in activity question, sir. Activity 1.8.
Okay, so can we finish the summary? Then your doubt then I can take your doubt. That would be good. Or later means to say after 1 hour or 1.5 hour. It would be if I am taking your doubt after that. It would be good.
Okay, sir. Okay.
Yeah. Okay, so in the if you see in the first lecture, so I talk about the numbers and their operation. So numbers is generally you can say the first number in the counting is you can say natural number. So in this lecture, in this course, I will say not in this course, even I will say till half of the before starting to the calculus, which will start from week 7, I think 7, 8, 9. Yeah. So before that, you can consider whenever in the quiz you will see there will be note, a note will be written that when you will consider the natural number will be a 0 will be a natural number, and when you will consider the 0 is not included in the natural number. So for at least for week 1 and 2, or even I will say for at least for week 1 only, you can consider that natural numbers are started from 0, 1, 2 till infinity, you can say. Yeah, generally it is a convention that not it is a convention, I will say. Generally, the natural number you will ever, as you used to say, it started from 1. But I will say for this course, at least for this course and for Maths 1 week 1, you can consider the natural number started from 0. Why? Because sir have mostly because of it is a computational thing, and we uses the like computer is you can say most of the time uses 0 and 1 kind of thing, like it is a uh, on off kind of thing, but in mathematically it is represented as 0 and 1. So that's why sir have just considered a 0, otherwise there is no specific mean. So for this course you can consider that natural number, not even this course, for week 1 you can consider that the natural number started from 0.
Sir,
Yeah.
yes, sir. So like somewhere it is also related to binary.
Yes, yeah, that's why I'm saying it is a binary. Because of the binary, it sir have included 0 as a natural
Okay.
number started from 0.
It just sort of just to justify the binary 0 and 1. That is the reason why we consider 0 as one of the natural numbers.
Yes, that's all.
Got it.
So this is about the natural number. The second thing is about the rational number. Okay. So rational number is nothing but it is a form, you can say. any number which is written in the okay, so any number which is written in the p by q form where q not equal to 0, you can say that is a rational number. That's what, like for example, you can say any all natural numbers are rational numbers. 1 by 2, 1 by 3, all are. So any number which is written in the p by q form where q not equal to 0, you can say that's a rational number. That mute all. Okay.
Hello, sir. Good morning.
Yeah, hello.
Hello.
Yeah, hello. What's your good
Good
name?
morning, sir. Sir,
Good
can we
morning.
consider a rational number as a real number?
Yeah, rational numbers are actually real number.
But there is a question in assignment, I think. It's fifth or sixth assignment. In that question, they ask choose the real numbers count. So there is a one rational number, but the answer consider that rational number is not considered as a real number.
So that is, can you tell me that number? What is that?
I think 3/5.
3a.
No, 3/5.
5. 3 upon 5.
5
So
not.
this is a rational number, and also so see, mean to say rational numbers are generally denoted as a q. So here you can consider the natural number. So if you little bit know about the set theory, so natural numbers are subset of natural numbers are subset of rational number, and rational numbers you can say subset of real number. So this is one thing. We'll discuss that about the set theory. Yeah.
Yeah, I have a query related to pi is an irrational number, right?
Yes, pi is a pi. Yeah.
When you write a pi in the form of 22/7, right? 22/7, it's a rational number or rational number?
No, so see, this pi is, see, that's why I'm writing here not equal to. I am writing the approximating sign. This is equal to, so means approximate to 7 by 22/7. And actually, if you count that, this is 3 point something till some after point, maybe 1, 2, 3, till the one, like some point, it will be the equal to the pi, but it is not exactly pi. So it is approximately, you can say, or some till 10th or 12th decimal point, you can say.
Yeah, because
20 decimal. Yeah.
Yeah, why I'm asking this question, right? Because one of the option in the regular assignment, non-graded assignment actually, where we have a variable called some pi by 12 actually. After certain point of time, it is looks like going on a cyclical. The decimal will go on a cyclical 58333. I thought it would be irrational number actually because of this. It's going on cyclical, but when you in this course, right, when we consider the 5/12, so we always keep it as a p by q, p not when p z not equal to 0, right? That's why we consider
so
rational,
let me tell you how. So let me tell you how we'll differ that number that is a rational number, and the number a number will be rational and or irrational. So here is, if you suppose the numbers are kind of, suppose I'm writing 3.14567, see that it is always, here the numbers are always changing. Okay, this is 1, 0, always changing, and it is an infinite kind of thing. Okay, it is always changing, it is not repeating. The, like suppose it is after some time, it is not always be 8, 8, 8 continuously 8. It would be always changing. After 8, it will be 9. It will be 1, 0, 7. If it is not repeating, then those numbers are actually irrational numbers. And apart from that, suppose a number which is, Suppose this is a number and after some time it started repeating. Suppose 888 or 555, it started repeating. So those number is actually rational number. So
Oh, okay.
irrational number is the only thing that if you convert that irrational number in the decimal form, this in the point form, so it will be always, it will be not repeat. Any number cannot be repeat after some time. It will always change. Okay, it is always change. Those number will be irrational number.
Okay,
Except
so
that all numbers will be rational.
okay, thanks for the text.
So this is the difference in irrational number and rational number. By using this way, you can say that a number will be a rational or irrational.
Okay,
So
okay.
suppose if you see that root 2, if you find root 2, this is an irrational number. But how we will know that this is a irrational number? So there are two conventions that either you can prove that this is a irrational number. So you can assume that, okay, if you are assuming this is a rational number, so suppose this is a rational number, which is written in the P by Q form where Q is not equal to 0. Once you prove, sir have solved in that video, in the lecture, that how we'll prove that root 2 is a rational number. Because finding the root 2, okay, finding the root 2 in decimal, this in point form, you cannot find the all. You are not very much sure that after some time it will not repeat. So for that, generally you can assume that, okay, this is a rational number, and why using the contradiction as sir have did in the video lecture, if you've gone through that. Using that, you can say that, okay, root 2 is an irrational number. But in a pure way, you can say that a number is a rational number when this condition will happen. Otherwise,
It's not
that
irrational,
will be-
sir. It's not, root 2 is not irrational, but it is a real number, right?
Yeah, so root 2 is a rational number, irrational number. So this is a rational. So generally, rational numbers are denoted as a Q, and irrational number is, you can say, the component of Q. Sorry, the complement of Q.
Yes, sir.
Okay, and this whole thing make as a
Real number.
real number. Okay,
Hello.
so irrational numbers are, you can say, are actually a real number. So rational and irrational both are real number. Okay.
Good morning, sir.
Good morning.
My name is Alitur.
Yeah, your voice is
Uh,
breaking. Others,
Sir,
I'm not able to listen you clearly. Can you check your internet connectivity, please? Okay. So this is all about, I think, the number. And operations will not discuss much about, like, as you know, the operations is generally, you can say, addition.
I have a question, sir.
Yes.
Sir, in the lectures, Professor Madhavan also touched upon complex numbers. So,
Yes.
like, can you also tell us that how does complex numbers
Yeah,
play in
so
this
let me
picture?
tell you a brief. Yes, let me tell you a
Yes.
brief. So how the complex numbers. So one thing I want to make sure that in this course, even I will say, not even this week on Maths 1, in this course, the whole course, BS in data science, you will not taught or you will not see the complex number, at
Right.
least. So only the real numbers you will, whatever you will did on only on real numbers, the complex numbers are not there for this course only. And let me tell you the brief or a small thing how the complex number came. So
Yes,
if you
sir.
think that if this thing is happening, suppose you want to find the solution of this equation, you want to find such number that this become, if you add with this number, it becomes 0. But this will never happen. The reason is, if you want to find the real numbers, and if you take the square of it, it will always positive. If you add, see, 1 is a non-zero number, okay? And if you add any non-zero number with 1, okay? So it will never become 0. So what we find, how we will find the equation, or what numbers we can find so that it become, if you add with that after squaring that, what if you add with 1, it gives 0. So this arises a complex number. So generally, you can say, if you know that the complex number, or so this is, if you take the root of -1, so this keeps I, it is a notation. Okay, this is a notation. see, root over only we used to take the root of only positive number. Okay, because the reason
Yeah,
if you take
like we are forced to take a root of negative number here.
here is we are forced to take, yes.
Yes.
So that's why we just gave a, see, I is nothing but a root of -1. So here forcefully we are taking, and that's why the another number came, that is called you can say complex number. And any complex number generally it is a kind of a plus ib, where I can generally denote at a -1.
Yes, sir.
And
So,
other
sir, like this one question arises that this complex numbers are not part of the real numbers; they are separate.
yes, so yes, the complex number is separate. There is no, you can say if you are denoting the complex number as this one, so there is no connection between the complex and, oh no. So you can say real numbers subset of complex. This is one thing.
Okay.
Okay.
All right.
So complex number, the whole numbers, you can say whole numbers, but for this course we are restricted to till only the real number. But real numbers are actually subset of complex number.
So complex number is just like it's a basically an extension of real numbers.
Real extension of real. So, but now we will not talk about the complex number. This much is information is enough to know about the complex number, because we are not considering the complex number. So don't worry with this one. We are only till here. We not
All
go
right, sir.
or will not study the extension of real number or
All right,
the
sir.
numbers on the complex.
Hello, sir.
Yeah, hello.
The real number is a subset of complex number, sir.
Sorry, I'm not getting. So one by
So
one.
what is the irrational number?
So first thing,
real numbers are also complex numbers.
yes, real numbers are also complex.
Complex number is to universal set of numbers.
So don't worry. Don't worry. Okay. Now just forget that there is a complex number for the timing. If you start talking about the complex number, it will not finish. Okay. So just know that, okay, we will talk only the real number. That's all. I'm also not going to discuss about the complex number. For
So
the
what
curiosity,
difference?
I just, yeah.
So what's
So
difference
can
between whole number and natural number?
So for this course, there is no difference. You can say the whole number and natural number. The whole number also started from 0. Natural number for this maths one or even for this course is started from 0. So you can say for this course, there is no difference in the whole number and natural number.
Hello.
Yeah, hi.
Sir,
What's
agar
your
my
good name?
question, sir, if in the question we have a set of natural numbers, does we include 0 in that or not?
So, sorry. What's your doubt?
Sir, if we have a question in the assignment which we have given a set of natural numbers, so we take 0 as an element in that or not?
Yes.
We take 0.
Yeah, you take 0 as a natural number.
Hello, sir.
Okay, sir.
Yeah, hi. What's your good name?
Mohit, sir.
Yeah, hi, Mohit.
Sir, how to check any equation if this is irrational?
So if you want to check that number is irrational number, okay, so there is, if you go through still I think there is not added the FAQ. Okay, in the supplementary content I will again tell.
Yes, sir. Please do add the FAQs. It was very helpful.
Okay, so yeah, it will be added. Okay, well, it will be added FAQ. So in FAQ, you will see that how will identify a number is a not rational or it is a irrational number. So generally, you can say a non-perfect root of non-perfect square number. You can say. Just a minute.
Hello, sir. I have now.
Just a minute. Sorry. Okay. So. Okay. So non-perfect is root of non-perfect square means to say that suppose 2, if you are taking 2, so is there any number, if you square that, then you will get 2. So such numbers you can say 2 is a non-perfect square number. So if you take the root of such number is actually irrational number. Okay. So like
Can we
5.
prove log 2 as a irrational number?
So suppose you are taking 5, no? So 5, is there a number that if you are doing a square of that and you are getting 5? No. So then if you take the root of 5, then it is actually irrational number. Okay. And like suppose you are taking 25, or even let me say you are taking 16. Okay. Or let's say I'm saying the 4. So 4, if you are taking 4, so is there any number such that if you are taking a square if you of it, it's give 4. So yeah, you have a number 2. If you square it, you will get 4. So that's why 2 is not, if you take the root of 4, so this is not a irrational number. This is a rational number. Okay. So this is the difference you can say, or you can identify using this, that a number is a rational or yeah. Hi, what's your good name?
Sir, my name is Gupta.
Your
Number.
voice. Last time you also admitted your voice is breaking. I think others, or I think
Hi.
Gupta, whatever
Good
you are
morning,
saying.
sir.
So your voice is
Log
actually
2 as an irrational.
sorry. One by one.
Hello, sir.
Yeah. Hi. What's your good name?
Sir, Neeraj Kumar.
Hmm.
Sir, if we don't study in complex number, then if question asked and his solution is a complex number, then if question
No, never such thing.
asked,
Okay. Never will. It will never happen. Okay. Don't worry. It will never happen.
Hi, sir. Good morning.
if solution is complex number, then I told there is no solution.
No. So such question will never asked, I will say. Okay. We're having the only if you want to give the answer for that, so only you will give answer for real number. Whatever if you are getting real number, then otherwise check your solution. If you are making mistake. Okay. There you are making.
If question tells how many solutions and then complex number include then solutions, so I tell only real solutions.
Only real numbers. Yes, only real number.
Okay, thanks, sir.
Hello. Hi.
Yeah. Hi.
Am I audible?
Yeah, you are audible. What's your good name?
Sir Rajiv. I'm trying to.
Yeah, Rajiv.
So I just want to clarify, not just go in detail. Here you said that real numbers are a subset of complex numbers. It means every rational number and irrational number is a complex number.
Yeah.
Okay.
Yes.
Second,
yeah,
we have raised hands, and I think everyone is speaking. So we should lower down our hands.
No, I will say keep it as, because after this summary thing, maybe I will take one by one your doubts. So if your doubts is clear, then you can put down. Otherwise, still your doubt is there. Please continue with the raising hand.
Sir, I have
so it will maintain the continuity that okay, someone is late, someone is after that he have raised, so still you will be in the first. So let's continue with the raising hand. If your doubt is resolved while listening this, then you can put down your hand. Otherwise, keep it as that would be good. Okay.
Sir, the same issue I have, sir. Actually, we have raised hand 30 minutes ago, sir, but we didn't get a chance to ask questions. Sir. People are just entering and just asking random questions, sir.
So random question is mean to say I am making a summary thing, or we are discussing something. If you have means your raising hand is if your doubt is let's say particularly activity or practice, then I think you will raise your continuing the raising hand. Otherwise, if not,
actually,
then
sir, my concern is, sir, please, sir, like you just, I'm saying that, sir, you just please continue, sir. Don't take a questions right now. If people have a question, sir, they just jot it down. And once we finish the class, I mean, once you finish all the topics, sir, then they will issue like raise questions one by one, sir.
Yes,
yeah, I think so. It would be good. Otherwise, sir, it will not finish. Yeah.
Yeah, sir. That's what I'm saying. We are not going to finish, sir. We are just revolving around natural numbers and these things, sir. And when are we going to touch, sir, functions, sir?
Yeah, we are very soon. Now I am moving to the this much talking about this about the numbers is enough. Now I am moving to set and then relation, and next is function.
Yeah, that's what I'm saying, sir. Please don't take a question right now.
Okay.
You just finish
No
all
issues. Let me finish that.
Yeah.
Okay. Perfectly. No issues. Okay, so let's continue with the discussing thing. I will take your doubt first. Let me finish that very quickly, and then doubt will be open. Maybe you will get the idea. Your doubt will be resolved while discussing. At the end, when I will stop discussing thing or the summary thing, then you can ask your doubt. That would be good. Otherwise, I will not able to finish the summary thing. So now let me move to this about the set theory. So set is nothing but the collection of well-defined objects. So what do you mean by that collection of well-defined object? So suppose you want to, set is nothing but, so it has some notation that whenever you are talking about, you will put the collection. This is a collection, no? So you are listing out some objects. So that object you will list in this curly braces. Okay. In the curly bracket, you can list out first thing, and it should be not a repetitive, and it should not be like, it should be a well-defined. So what do you mean by this well-defined means? Suppose I am saying to you that please collect the wise student in your class, yeah, or please collect in your class. Okay. So this is not a well-defined word to say that uh, how you will collect this. No one how will collect that wise student or wise classmates in your class. So how will collect those? Because no one think that I am not a wise. I am not a wise person. So that means here is not well defined as happening. So well defined means it should be properly clarified, classified that okay, I may able to collect those all. So suppose you want to see these numbers of this much student in your class, you are becoming you are started collecting the wise person. Okay, you took this person and said you are wise. He said he will never so that he will never say that I am not wise. Okay, so this is not a well definedness of, that's the meaning of well defined. So it should be proper classified, well defined, that okay, you are taking those collection. So set is nothing but a well defined collection of well defined object. And one thing, and the second thing is, whenever you are taking, the elements should be not repetitive. So if you are suppose now I am taking some numbers, suppose this is 1 2 3 2 4. So this is a set, fine, but whenever, so this set is actually equal to the set 1 2 3 4. So you will not take the, so you will not consider that the repeat will happen. Okay, this is one thing you will, and it should be, the bracket should be curly brackets. So this is the notation. This is all about the set. So there are two ways to defining a set, or there are two notation you can say. Either you can list out the all objects. That is one thing to notate a set, or there is another thing. The set comprehension is called. So generally the set comprehension is used for the infinite set. So suppose you want to collect the all numbers, natural number, which is divisible by 2. So if you have started listing out, so 2, 4, 6, even the 0 will also divisible by 2, 2, 0, 4, 6. So how will collect those all? So it is difficulty to list out these all. So that's why the set comprehension is came in the picture, that how will notate, how will collect those all number in a set. So then you can say the set comprehension is a kind of, let's say A is a natural number, then the set comprehension is kind of this way. If you see in the book, it is properly written also. Let me show you in the book what are the difference uh, in the set comprehension. Let me show you what you call also. See that this is the thing. This is called transform or something is there. This is called generator. This is called filter. So you will see when you see the example, you will see that, okay. So this is just naming it. There is no mean to say it is, our question will be asked which one is in a set or set comprehension, which is transform, which is an generator. It will never ask you, don't worry. Just for information, I am saying this is, you can say the set comprehension, and some name have given to this portion, this portion, this portion. So don't worry if you are not getting, forget about, just for the time being, you can listen that this is happening. The notation in the set
So,
comprehension.
sir, it's like sort of a generalized statement which we write
Yes.
for sets which are having infinite elements.
Yes. So as the requirement happen, the notations or the things usually happen, like how you list out that infinite number. So that's why the set comprehension came. So generally you will say A is a natural number. Okay, this is denoting that A is a natural number, but we are collecting the even numbers, you can say, are divisible by 2. So you can say A mod 2, or directly you can write A is divisible by 2. You can write, or A mod 2 is 0. So here is mod is nothing but A mod 2. Here is mod is generally, you can say, a operation. So mod means, here let me write it. Suppose you are writing 5 mod 2. That means you are collecting only the, here it means that when you are dividing, what is going to be the remainder. Okay. So here is when you are dividing, what is going to be the remainder. So you will get remainder here 1. So here that's mean here it is saying that when you are dividing a natural number with 2, you are getting 0. You are collecting those natural number here. Or a different way you can notate is A, such that A belongs to natural number, comma, A mod 2 equal to 0. This is the collecting all number which is divisible by 2, all natural number, and or you can say the even numbers. So this is one notation is there. So this is called set comprehension. Okay. And now this is all about the set. The next thing is operations. There are some operations on the set. So what are those operations? So let me tell you about the union. Okay. Intersection. There are some operations. So suppose this is a set and this is another set. Okay. I'm taking two sets. So as you know that in the real number, you can add two real numbers. You can divide or you can subtract. Similarly, how we will do the some operation on this set? How we will do that? So for that, there are different operations. In place of addition in real number, there is, you can say, in the set, union is there. Okay. There is intersection. There is set subtraction also there. And complement is there. So there are, as in real number, some operations are there: addition, subtraction, division, and mod also, you can say, there in the real numbers between there is a mod operation, you can also include that. So there are something. So similarly, set is like now you are collecting, or you are in the world of collection of sets, and you want to define some operations there. So operations are, you can say, union, intersection. There are other, we'll see it. Okay. Or you can see in the book also, some operations have noted here, I think so. Subsets are there, we'll let you know. Others, here is not listed out, I think, or here is relation is given. Okay, we'll see it. So let me tell you that what is a union. So union is generally denoted as, if you have a set A and this is a notation U and this is P. Okay, it means that you are collecting. Now let me write in the set comprehension form. So this is an element, okay, such that you are collecting all those elements which is in A or A in B. This is mean you are collecting all those elements which is either in A or in B. Okay, this is the mean. Or you can say, okay, suppose this is the notation form. This is the collection of, or this is a set A and this is a set B. So A union B is nothing but the whole this set. This is the mean. Okay. Now next thing is A intersection B. So A intersection B is, let me tell you now the notation in this pictorial form. This is called Venn diagram actually. So suppose this is set A and this is B. So A intersection B, this is the intersection notation, or between, this is an operation intersection between two sets. So A intersection is nothing but you are collecting those elements. Let me mute to all of them. Okay. So you are collecting those elements which is here, which is in both sets. And in notation form, in the set comprehension form, you can think that A such that A belongs to A and A belongs to B. This will happen. Similarly, other notations are there. A complement. A complement, whenever you talk about A complement, there should be a superset. So what do you mean by superset? Let me tell you about the subset thing first. So, a set A is said to be subset of B. What it means that when it will happen, when all element in this set is also element of this set, then you can say A is a subset of B. And the superset, here you can say the superset. So B is a superset. This is subset and this is superset. Okay. This is two things. So whenever you talk about the complement of a set, surely there should be a superset. With respect to that, you will talk about the complement. So what it means that, so this is, you can say, a superset now. This is the collection of, and here is your A. Okay. So complement of it means you are taking the collection of those elements which is out of this set. So this is actually a complement. So whenever there is a complement thing, okay, so a complement means there should be a superset. With respect to that, you are talking about the complement. So you can say this is generally this is a complement means whenever we talk about that, you are generally say the universal set. This is, you can say, universal set. Here is nothing but you can say in with respect to this, B is actually universal set. But now we are in notation form. So I am notating it that this bracket, or sorry, this square is actually the universal set. With respect to that, you are talking about the complement.
Sir, like I have a question regarding this. Can you go over this or and notation of yes, that is a bit confusing.
Okay. So here is, I have just wrote that or and is here. So here or means, let me say A is here 1 2 and B is 2 3. So I'm taking A union B. So let me read out this. So I am saying A belongs to A. A is, this set is, this union is nothing but the collection. What is the collection? Either A belongs to A, either A belongs to A or A belongs to B. So see that let's start the listing out. How we list? Okay. I am taking the operation. I took 1. So 1 is, see that 1 belongs to A. 1 belongs to A. Or 1 belongs to B? No. So I took 1. Now I am taking 2. So 2 belongs to A and 2 belongs to B also. But here is or word. So only you will consider once. So here means A belongs to A or A belongs to B is happening. So I am listing out those elements either is in A or in B. This is the mean.
Okay, so yes, either in A or B. So it means like all the elements of A and B.
A and B. You are listing those all elements.
Does a union. All right.
Yes. And intersection is now over here is and what is there. So you are taking those elements which is in both A and B both. So here is, see that 2 is in both. Otherwise, there is no such element which is in both. Only 2. So that's why here is the difference. You can say and is there. A should be A and B also.
Yes, this single element should be present in A and B. Thus an intersection.
Yes.
Yes, sir.
So this is the difference in and or, you can say. Okay, let me go with next thing. No, so let me finish it. Let me finish it first. Okay, let me finish it. I just took, because this is a unique doubt. Okay, so let me finish it. Okay, so the next thing is, so there is one thing also I missed, that empty set, about the empty set. So you are taking about, you are just, empty set is, there is no element in that set. It is notated as 2, this is a curly bracket, closed curly bracket, or you can say phi is also denoting as the empty set. There is a set which having no element. That is the empty set. One thing I missed, that about the cardinality also. Cardinality of a set. So cardinality is nothing but the number of count in that set. Suppose I am taking the set A, which is 1, 2, 3, 4. I'm let's say A, B, C. Let me mute to all. Okay. A, B, C, D. So if you want to count or want to find the cardinality of that set, generally it is notation is that it is denoting the cardinality of the set A, or generally also cardinality. Okay, there are many ways. You will very much clarify in the quiz or in the practice or activity. It will be very much clear that what is asking. It is in this notation or in this notation. Okay, the word surely should be written the cardinality word. So cardinality of this set is nothing but the number of element in that set. So here is A 1, 2, 3, 4. So cardinality of this set is 4. This is the mean of cardinality. If a set having infinite number, so just say that the cardinality of this set is infinity. Okay. So generally this question will not asked in the will not see anywhere. Maybe in the option wise it will be given. If you say that it is in the numeric form, never it will be asked.
Cardinality of a null set will be 0.
Yeah, cardinality of the null set is 0. So this is all about the set. Some operation I talked about. Yeah, there is another operation you can set subtraction, you can say. So A, this is denoted as A/B, you can say. This means that you are collecting those elements. Let's say this is set A, this is B. So set A minus B means you are collecting only those elements which is out of this. A is still here, but I am collecting those elements which is not in B, and collection of those are. Okay. Here mean to say, let's say I am saying A equal to again 1, 2. Okay. And B is equal to 2, 3. Okay. So here is A minus B means you are taking all those elements. Okay. Take all those elements. Okay. One I took. When I am started taking 2, but 2 is actually in B also. So you will not take those all. So you are collecting those elements which is in A but not in B. That's the meaning here, set subtraction, or you can say here is A minus B. Notation is in this form. You will not see like this. Okay. It is generally you will see like this. Or you are supposed, if you see it like this, that means you are taking all real number. Okay. But this set is not contain 0. This is the mean. This is the set subtraction, you can say. So this is actually this one. So this is one thing. So, and this is all about the operation also, I think. If I will miss, I will later discuss. Okay, now let's move to the relation. Important topics.
Sir, question number, sir, based on this topic, there is a question in activity 1.5, question number 7, sir. You will take it later, sir.
Yeah, I will take it later. Yeah. Now let's move to important topic. I have seen many doubts about the relation and function. Let me talk about these two. Yeah.
So you missed the power sets.
Okay. Yeah. Let me. Yeah. Okay. Power set is there. Yeah. There is another thing. Power set. So power set is, suppose you have a set. Okay. Suppose let's say 1, 2, 3, 4. This is a set. So power set is power set of A. You can say this is the collection. This is power set is nothing but a set. Okay. This is one thing. But this set is actually now this set is actually the collection of all subsets of A. So let me tell you that. See, if you started listing the subsets of A, what will be the possibility? Okay, so this is one subset. Okay, this is a one type of subset, you can say, collecting the collection only single element. Now the another one is 1, 2. This is 1, 3. This is 1, 4. Okay. This is another type. Similarly, many times either you can say still you can start with the 2, 2, 3. So these are all subsets. So mean to say powers is nothing but the collection of subsets. And also it is power set of A means collection of all subsets of A. So here is, this is, we are collecting all, this is single type. Okay. And also list out double pertaining to this cardinality of 2 subsets which having cardinality 2. Similarly, list out the cardinality.
5 will also be there now.
Yeah, I missed that. Empathy set also will be there. Okay. So let me tell you, the empathy set is actually a subset of every set. Every set. Empathy set is, or empathy set generally, empathy set is subset of every set. Okay, so that's why 5 will come under this power, and also A will also come in this. So power set is the all possible collection of all possible subset. This is the power set. Okay.
So
and how
phi is always
5 is always a subset of every set. And if you count, if you want to count that what is going to be the cardinality of the power set, so it is nothing but the 2 to the power n, or the, you can say, cardinality of A. Okay, cardinality of A.
So the statement that 5 will be element of every set is very confusing.
Subset of every set.
Yeah,
subset
of every set. It is very confusing because, in my opinion, it can be a subset of only those sets which are collection of other sets.
No.
If we talk about A here, it cannot be, 5 cannot be element of A here. A is a set, but
not element, not element. Again, I will say not element. So don't be confused with the not element and subset. Okay. I think you are missing that because of the element word you are adding. Otherwise, phi is subset of every subset, because the reason is it doesn't contain any element which is not in A. Okay. That means it contains an element which is in A, but at the end you can say there is no element. So that's why phi is a subset of every set.
Yeah, got it. Okay, clarified.
Okay. Or otherwise, if you are getting the confusion, so just you can think that this is a convention that phi is a subset of every set. Okay.
In cardinality, we are always at phi.
And cardinality of empathy set is 0. So let me finish now. Next thing is about this is done. So I'm now, let me move to the relation thing. It is important and function.
Sir,
Let me quickly do that.
Sir,
yeah. Hi.
can you explain binary number?
No, we'll not discuss about the binary number because we don't have time for this one. If you have time, then we'll discuss about
subset A, sir, that I can't understand, sir. The 2 power and subset A.
Yes. So let me finish it. Let me finish it. So yeah, so what I said now, cardinality of the power set is 2 to the power cardinality of A. This is, for example, let me take it here. Suppose what is the cardinality of A? Cardinality of A is 4. Okay. So if you want to find the cardinality of the power set of A, so that means it would be, so that means this is a power set. What is going to be the cardinality of this one is 2 to the power 4. So this is going to be your, what is going to be, it will be 16. Okay.
The number of subset and power set are same.
Number of subset and power of, no, number of subsets.
Yes, sir.
And the number of subsets and the cardinality of the power set is same, you can say. Okay. Number of subsets. So number of subsets is actually, so that's the you are collecting, number of collecting, you are collecting all those subsets. And in that you are collecting power set is nothing but the collecting, you are collecting all subsets of A. So that means you can say the number of subsets is actually, that's the word I am using, the for the cardinality of power set. Okay.
Okay, sir.
So this is the, you can say, here. Is it?
I have a major doubt here. While doing practice assignment also, I found this. If any set contains 4 subsets, then the cardinality should be 2 to power 4. But here we also said that
no. If it is contain 4 subsets, so 2 to the power, it will be not 2 to the power 4. You need to count the number of element in that set. Then
I think he means 4 elements.
Okay.
Yes, 4 elements in the set. I am talking about, if I talk about power set, kind of power set, subset of power set. For example, a set contains 4 subsets in it. Then if I treat every subset as an element, then there should be 4 elements, and the cardinality of that element, set, overall set, should be to the power of 4, that is 16.
No, okay. I didn't get your question because you mixed with the subset and element. Let me finish it. Then you can indicate the question in the active or practice.
Sir, is null set included in power set?
Yes, null set here is null set means empty set. That's all. Null set is nothing but the empty set.
Okay, sir.
Okay, so let me continue with the relation in the relation. Let me finish it first. Let me finish it. Then we'll discuss. Okay. Otherwise, I will not able to finish that. So relation. So your doubts, particularly in activity or in the concept. Let me finish it. Then you can unmute and then start.
So my doubt was just related to this. Wanted to clarify. Want to have more clarity on my doubt. If I have collection of subsets of a set,
okay,
then what should be the cardinality of that collection of sets?
That's why I'm saying if you're collecting all subsets of that set, that is you are making a power set, and that is the cardinality.
No, I'm not collecting all subsets. I'm collecting
some specific number. Okay, let me. So that is one thing. Okay, good thing. Okay, let me. I'm taking a set. Okay, which is not a power set but different from this power set. Let's say I'm saying. Let's say this is let's say set B. I'm taking set B, which is the collection of some subsets. So this is one. Okay. This is, let me 2, 3. Let me take 1, 2, 3. So this is a subset. This is a subset. This is a subset. All are subset. Let's say this is 2 here. So I am this much I am taking. So see that this is one single element. This is one single element. This is one single element, and this is one single element. That means B is actually the collection of subsets of A, and it has 4 elements. So cardinality of B is actually 4. Not the it is not power set. See, this is not a power set. Now you are not collecting all subsets. You are collecting some subsets of A. So this is one single element. This will be a single element. This will be and this will be a single element.
So the cardinality here is 4. So
yeah, cardinality is 4.
Here we missed 5. Should 5 be included if we are taking
no 5 is a subset. No, but you are collecting specific. You are taking some specific subsets.
So when we are calculating the when we want to find out the cardinality of a set, we don't take into account 5.
Yes. Yeah. Now, if you suppose I am adding here 5, and then this is the collection. So for this set, cardinality is 5.
But like we had to already assumed, right, that 5 is always a subset of every.
Yeah, 5 is always a subset of it, but I am not collecting in that set B.
Okay, so when we are specifically calculating the cardinality, we don't take into account 5.
Yeah. See, 5 is a subset, no? So I am in this set, I am not including that 5. I'm not considering all. This is power set is actually the collection of all subset, but this set B is I'm specifically choosing some subsets. So I suppose in starting I choose only these subsets. So only I will count those number. Suppose I chooses 5 also in that set. Then the cardinality will be different. In that case, the cardinality is 5.
Got it.
Got it, sir. If we talk about all subsets, then we include 5. Otherwise, if we intentionally include 5, then we count it as cardinality.
Then we'll count it. Otherwise, we'll not count it.
Okay. Thank you.
So I think now you can move to relations.
Yeah. So
Sir, I have a question. So there is only 5 subset element. So what is the cardinality? It is 1 or 0?
No, just now I counted. No, in that case, the separately I count. If you are including 5, in that case, your B is 5. Cardinality of B is 5. You are here, no? Just now we talked about, so you are listening, no? Let me mute to all first. Okay. Now let me continue with, yeah, just rewatch it again. Okay. I'm suggesting you just rewatch it again. It is live. So you can rewatch it again, because it is a very much clear on, and also I spent time much on here, the power set and the subset of sub collection. Okay. Let me move ahead about the relation. So before talking about the relation, there is one concept that, let me open it first, then it will be more clear. Real complex set theory, construction of subsets. Okay. Set example, set operation, real. So Cartesian product, the word is there. I want to show you. So no issues. So no, yeah. Okay. Okay, so there is one word, Cartesian product. Before talking about the relation, okay, there is one word, Cartesian product. What do you mean by that? So what do you mean by this is, suppose we have a set A. Okay, I am taking another set B, and I'm defining. So this is a defining. What I'm defining, A cross B. Not I am. Actually, this is a mean to be the Cartesian product. So means, what do you mean by you are defining this? This is a set, no? This is a different set. So, but it have, that's why the word defining word is there. How it will be defined? How this operation you can say it will be defined, or how this notation A cross B, how this notation can be defined. So let me define it here. So as the definition for Cartesian product is, you are taking the collection of all pairs A, B. So let me in the set comprehension notation, let me follow. So this means you are collecting the all possible pair. This is, see that this is in the pair wise. Okay, this is one thing. And where A belongs to A and B belongs to B. This is the mean of Cartesian. So this is the definition, you can say, a Cartesian product. For example, let me take, let's say A is equal to 1, 2, and B is, let's say again 2, 3. Okay. So A cross B, which is, now collect those all possible pair, which is possible pair is, let's say 1, 2. You take first and then multiply with each element. Multiply means take the pair with each element. Take one first and then
take one element and pair it with another element.
Pair with the another set B. So that means here is 1, 2, 1, 3. This is 1. Now take the second element, which is 2, 2, and 2, 3. So one thing I want to note it here. Here in each pair, you will, in the first coordinate, this is called coordinate here. The first, this is called first coordinate, and this is called second coordinate. You can say the word coordinate also. You will see it in the second week also very soon. So here is, this one is always be the element from this set. This one, first coordinate will be element of this set A, and the second coordinate will be element of B. If you see clearly, this is the mean here. So this 2 is for this set. Okay. This is the mean. So this is actually the defining set. Here you can say that this is the called Cartesian product. Okay. Now one thing is here. Now the relation word came. Okay. I am taking a subset. See, this is a set now. Let me erase it here. mute to all. So see, this is a set. This is a set with the different. Here the elements are in the pairwise. Now I'm taking, so this is a set, I'm taking a subset of this Cartesian product. Let's say R, I'm saying R. This is not the whole, this real number. This is generally notated R. So R is, I am taking some subset. So I am taking a subset of this Cartesian. Let's say I'm taking 1, 2 and 2, 2. Okay. Now I am giving the name of this R as a relation between A and B, or generally. So relation is nothing but a subset of the Cartesian product. This is the definition.
So we have just taken these two elements randomly, 1, 2 and 2, 2, and we are just calling it a relation.
Yeah, we are just calling it a relation. So let me, it is a set, it is a purely set wise. I will give an example with the our real word. So this is the set wise definition. So in purely, relation is nothing but the subset of the Cartesian product. Okay. So in notation form, you can say this is notated as A, B. This is called domain for the relation. Okay. And this is called codomain of the relation. There is two things. Okay. This is in the relation form. This is the notation generally. No need to remember it, but I'm just saying that this is a, see, this is also very similar to notating as the function, but here is, yeah.
Sir, how the relation is 1, 2 and 2, 2. Sir, that 2 is related, that only also.
So let me tell you, I'm not saying any word I use is nothing. I just took a subset. I'm saying this is a relation, and this is actually a relation between set A and B. I'm not saying the related word. What is the related word is here? I don't know even. I don't know what word I'm using for the related word. I just took a subset of the Cartesian product and collected in the set and said I'm saying R is a relation between A and B. That's all. So now here is, you can say 1 is related to 2, but I don't know this word relation is what, but I'm just saying 1 is related to 2, 2 is related to 2. Here it means that here it is, we are noting. So this pair is actually nothing but the relation word. Now you can say 1 is related to 2, 2 is related to. Now let me take an example. First, let me take a real example, then it will be clear.
Thank
how
you,
it
sir. So I have clear, sir. Thank you, sir.
Okay. So let me take an example. Suppose I'm taking a set, yes, which is a collection of a family member. Okay. Collection of family member. Okay. All family member. Even I will say all family member. Now on this set, I'm defining a relation that, okay, A is brother of B. List out that those all elements. I'm defining a relation on this set. So how it will be? I'm defining a relation on this S2 on the same set S to S. So what it will be? So R is actually subset of S cross S. This is the mean. I'm defining relation and I'm giving the relation. I'm in the real event scenario. I'm giving the word. This relation is an element is related to B if A is brother of B. Okay. Otherwise, so that means what it will come. Let's say, and the family members are here A, B, C, D. I don't know. Maybe it may be father, it may be mother. These are the son. Okay. Let's say this is C and D are son of A and B. And maybe let's say this is a grandfather. Okay. He is a grandfather. So what element will come in the R? A and B brother.
A comma A, I guess.
A comma A. A is brother of A. No. So this is a kind of ambiguous. So let me remove that. A, you cannot say A is a brother of A. Okay. So don't use this word. Now different person will be always.
Yes. So there's no repetition. Like it won't be B comma B, C comma C.
Yes.
We are not considering
it will
those
not happen.
things.
Yes.
So then then considering that it will be A comma B.
A comma B, why? A is son, I am saying father, and B is mother, and
Sir,
this
C
C and
comma
D are
D.
So C comma D.
Okay, okay, okay,
only
okay. Yes,
C
you are
comma D
asking
will
a.
come.
Okay, okay.
Okay, this is the mean. So this is the relation. Now you can say C is related to D, but here is relation is brother.
Sir, D comma C.
Also, yeah, I am missing that. D comma C will also come. Yeah,
Yes.
thank you so much.
Yes.
D comma C also
So
will
you were
come.
specifically asking for brothers.
Yeah, only brother.
Okay, all right.
I just missed that. D comma C will also come. Because you need to take yes cross yes. No, what will be the yes cross yes? A will come. Okay. Okay. Only yes
Yes, sir.
cross yes. I'm not defining here relation. I'm taking the Cartesian product. So A comma A, B comma B, other many element will come. But in that, this will come and this will come. And so that's why I'm taking a subset of yes cross yes. So this is our subset.
So you are taking a subset of the Cartesian product.
Yes, this is happening. So that's now what what I made in starting. This is I made, no? I just I took two set, I multiplied them, and I multiplied means here multiplication between two set is just called Cartesian product. How it is defined as here I just now defined here. Okay. Now I am taking a subset here that is called I'm saying relation. So this is happening. No? So the same thing is happening. I am defining a set which is a collection of all family member. Okay. And defining a relation on that set, which is generally noted as like this. Okay. What is happening? So R should be a subset of S cross X. Sorry, S cross S. So what is happening here? The relation is actually I'm defining two members will be related. Here is any two member will be related when those are brother to each other. You can say brother word I'm using as a relation here. Okay. So when I am using this word, so that's why the collection is coming as CD and DC.
So in numeric value, we give a condition, and under that condition, whatever comes.
Yes. Here I just given the condition. I just made a subset. I'm saying now here A1 is related to 2, 2 is related to 2.
Okay.
But I here as I word uses brother, but I didn't here use any word. I just say I'm related. I'm saying the word related. But that's all.
So just the main purpose of Cartesian product is just to make a relation between two
Make
sets.
a relation on that set. That's the
Okay.
meaning. Cartesian products, actually you can say actually this is called a binary relation. Okay.
Binary
relation.
Okay.
This is you are taking two set as in product. There is also got tertiary, okay, and also some other. But we for this course only will say you will see in the lecture video of after the 11th. I think so. Otherwise, I sir have some you read the word also. I don't know where is that. But we specifically here we'll see only about the binary relation. Okay.
All right, sir.
So here is this is a binary relation. Either you are taking yes cross yes cross yes, but I don't know how the relation I will define here. But
that is tertiary. That is tertiary.
Tertiary. So in that case, your element will become as A, B, C, D kind of whatever the element you are taking. So this will come, but we are not going to study it here. Okay. Only
Yeah,
we are
that was the doubt because like everybody got to know that what is Cartesian, how do we go about it, but we don't know the main logic behind it, that why do we do this. So it's basically in a nutshell just to make a relation between two sets.
Between two sets. That's all.
All right.
Okay. So this is called binary relation because binary means two sets I'm taking. Yeah. Hi. Okay.
In the set.
Yeah, Sanya. Okay, let me finish it. Okay, maybe your voice is breaking. So let me finish it. So on the binary relation, there are some specific type of relation, you can say. Now, reflexive relation or irreflexive is there. Okay, I don't think so. If reflexive, symmetric, transitive, antisymmetric till antisymmetric, this four, or even you can include the equivalence relation also. So let me see it here. So what is the reflexive relation means? Okay. Okay. So now you are reading out in relation, different type of relation, the reflexive relation. What it mean that? So let me give an example. So generally very much easy to on the playing this relation on the real number, but in the real scenario, in the reflexive relation is, can you give an real example which will be a set, you are able to define a relation that will be a reflexive? Not family member. That's why, let's say on mathematically.
Parallel line.
Sorry?
That parallel line.
So that's why let's go to on this mathematical word, and let's say the reflexive on the set of, let's say suppose I am collecting the set of all real lines. Okay. So no, so you don't know what is the Cartesian, that is a coordinate system. So let's remove that. Okay, we'll not talk about. Once you will read out the straight line, then we'll talk about. So let me tell you that a number which is let me take you another example. Let me just a minute. This is about the
Hello,
relation.
sir.
Yeah, hi.
Sir, I think if we write C comma D, then why repeatedly we write D comma C? Because if we write C comma D, then automatically D comma C is brother. Why we write two times, exchanging their position?
Okay, okay. So first list out the S cross S. Okay.
Yes, sir.
So in that you will find C comma D and also D comma C. And these two are
Yes.
different set. Okay, these two are different, sorry, different element.
In relation position is matter, sir.
Here is relation matter. See, C and D, C is brother of D, but
Yes,
you
sir.
are, you do now you are missing one. D is brother of C also, no?
Yes, sir.
So here is C is brother of D. Here is brother. And another thing is D is brother of C. That's why the repeating, not repeating, here is the exchange of the this. That's why these two came here.
Yes, sir.
Okay. Okay, let me take you another example. Let me write here in pure mathematically, I will say. So relation is, let's say R is a relation, okay, on a set S. So let's say S is, let me write here. S is actually, let's say 1, 2, 3, 4 is here. So reflexive relation is, you need to collect all those elements, okay, which is in the kind of related to itself.
We can take the example of greater than equal to S for reflexive.
Yeah, that's a good. That's a good. Okay, so I am defining a relation on this set. So R is, see that R is subset of S cross S. Okay, and see the element in R, how it is. So a number which is related to itself. Okay, we are collecting those elements. Okay, we are collecting those numbers. So a number which is related to itself, I am making a pair and putting in R. So see that this is means to 1 is related to 1.
So
2 is related to 2. 3 is related.
Sir,
No
it's a bit
yeah.
confusing. Can you go over reflexive again?
Let me tell you that. You are taking a relation. I am saying n is a natural number, no? So I am defining a relation on this set is two numbers. Two numbers related. Two numbers are related when I am defining a relation less than or equal to. Okay, less than or equal to. I am defining
this
a relation.
Is the condition. This is the condition which you have decided that if a number is less than or equal to this, then they will form a relation.
Then form a relation. So,
I think less than equal to won't work. It will only work for equal to.
Even equal to, yeah. So that's why. So see, I am defining. Let me tell you.
It will work.
It will, yeah. Actually, it will work. So see that how it will happen. So I am defining, or let's say I am defining. I am taking a subset, okay, of this natural number, which is, let's say 1, 2, 5, 7, 8. So this is a subset of natural number. Fine. I am defining on this set a relation less than or equal to. Sorry, less than or equal to. This relation is I am defining. Okay. So how it, so you are defining. So what are the elements will come in this set? Can you tell me in this relation? Sorry, what are the elements will come in this relation? Can you tell me what are the elements will come?
Sir, 1, 1,
1, 1, 2, 2, 5, 5, 7, 7, 8, 8. Okay. Now
1, 8, sir.
1, 2,
2, 5.
1, 5. 1, 5. Yeah, 1, 5. Like this, the element. See, this the first one will smaller, the next one is bigger. So A is related to B when A is less than B. This should happen. So these elements will come. So that means R will contain A comma B. So here is A comma B where A is related to B. That means here A is less than or equal to. If this thing is happening, then we include this in this R. So if you see that this is a reflexive relation, what it means that here each element here related to itself. One number is less than or equal to itself. That's the meaning, as you know the definition of less than and or equal to the word.
So, sir, relation this is a whole definition for a reflexive relation.
This is an old definition.
Whole. This meaning this is the explanation for a reflexive.
Yeah, this is the explanation. So relation, the reflexive relation is nothing but the relation in which the each element is related to itself. It contains more than that. See that it contains 1, 2 also.
Yes, sir.
But it should never happen 7. You cannot miss 7, 7.
So in a nutshell, can we say that a reflexive relation will have all the identity pairs, but it can have other pairs as well?
Yes, it can have other pair also, but it cannot miss even single pair. Like suppose you are erasing 7, 7, 7, 7, 7. This one.
Sure.
So it should never happen. If you are erasing this one, so this is not reflexive.
It must have all the identity pairs.
Yeah, that's the definition. No, each element is related to itself. This is the mean.
Sir, so it
Sir,
also
in that
means
case,
that
sir, the universal relation of a non-void set, I mean, for example, A is a reflexive also, right?
Sorry, I didn't get.
Sir, for example, like A relation R on a set A, I mean, which is said to be a reflexive if every element of A is related to itself, right?
Yes.
So in that case, the universal relation on non-void set A is reflexive, right?
What is this universal relation?
I mean, the whole set of A, sir.
Whole set of A.
I think Cartesian product.
Yeah, Cartesian product.
So you are taking the whole yes crosses. Yeah, this is a reflexive relation. Yes, this is a reflexive. So this is so you are taking a subset. No, you are taking itself that yes process. So that set even contain 1, 1. All it is containing those element also, the pairwise element. So this means so the simple definition is a relation said to be the reflexive. Okay, if each element of that set is related to itself. If it is not there, then that relation is not reflexive. This is the definition of, you can say, the reflexive relation.
So here in R you missed 8/8. That means it is not.
I missed that. Okay, I missed that 8, 8. In that case, this is not a reflexive. I missed that. So if it is any single one-to-one pair, that whatever you are making, if it is missing any one of the pair, then that relation is not reflexive. That means you are saying each element is not related to itself. If you are missing any one of them, that means you are saying each element is not related to itself. Only some pairs are related to itself.
Excuse me, sir.
You are missing them.
Sir, it's just like you had this one condition. I'm still not able to understand. Can you take another example?
Okay, so
yes,
within
okay. So can we term 1, 2 also as a reflexive relation?
It could be. A set contain 1, 2, but it should contain 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, whatever here is there. 1, 1, 2, 2, 5, 5, 7, 7, and 8, 8.
Okay, so
and it can contain apart from that 1, 2, 1, 5. That's all. That doesn't matter. But
so, sir, a set with the whole identity relation.
Yes,
with with everything else, but you need every identity relation.
Yeah, yes, that's the meaning here. Every identity related element should be in the reflexive.
Okay.
But sir, like for example, if you had given the condition A is less than B, so in that case, we won't be having the identity relation, right?
No, here is containing identity relation. No, one
Yeah,
is
yeah,
there, one
yeah,
is less
here
than
is
or
there.
equal.
Yeah, here is there, but it's not necessary, right? That we will always be having the
Yes,
identity
yes, it is
relation.
not necessary. Yeah, that's why this 1, 2 is also including in that.
Okay.
Okay. That's why it is happening. 1, 2 is there, 1, 5 is there because of this. Okay, let me take another example
Yes,
first.
sir. Yes, sir. That it will become more clearer.
Sir,
Okay,
can you
let me
take
here itself in the.
sir?
Sir, take less number. For
Sir, can
example,
you take
S
the
is
reference
equal to
from
1, 2,
lecture,
3,
sir?
sir.
So I want to suggest an example.
Yeah, can you
Take
suggest
example
me?
student of a class and
Mhm.
make it a product of that class.
Okay.
Have a relation of student between student as a student.
Okay.
So that
Same
make
height.
it
No, not same height. Yes, yes.
not
Okay,
they are
make
related,
it a same height.
Same height would
no,
work.
they are
Excuse me,
being
sir.
related as a student. Or you can take some other example, height
Let
or
me
something.
take an example. So suppose you are the
Sir,
same what he suggested. Yes is a collection of a class. Okay, collection of all student of a class. Okay, yes is a collection of all student. That means now I am defining a relation on this yes. Okay, on this yes. On this yes. What is that? That means R is going to be subset of yes cross yes. What is the relation? A student is related to another student or itself. A student is related to a student if it have same height. I am defining the
okay.
let me I have to define here. Here is one another relation is needed. Okay.
So I think you can take this one example which I read in the book. If you allow me, I can read it out.
What is that?
Yes. So it says that let's consider it's like suppose we have a group of 3 friends, Alice, Bob, and Charlie. We want to talk about the relationship of having the same favorite color. So it
Same
says
favorite.
that
Yes.
yes. So it says that in this case, the reflexive property means that each friend has the same favorite color as themselves. And it also
Yes.
gives an example that Alice has the same favorite color as Alice. Bob has the same favorite color as Bob. And it says that in the friendship group, having the same favorite color relationship is reflexive because each person's favorite color is always the same as themselves.
Yeah,
So can you
themselves.
explain this?
Yeah, almost you have explained that. Yeah,
I just read the book. I'm not able to understand it.
yeah, actually, that is a good example. So let me
So you
say you
can
suppose I am taking a set. Yes, okay, okay. Let me take let me take an example with the suppose Mahesh is there. Okay, Ramesh is there. Okay,
Yes,
older
sir.
name is there, and let's say Ganesh is there. Okay, I'm taking 3 persons. Okay,
Yes, sir.
and I'm defining a relation on this set that 2 persons is related if they have the favorite color is they have the same favorite color.
Okay.
Their favorite
Okay.
color is same. Let's say if Mahesh is saying to be red is his favorite color. Okay, so then we can say Mahesh is related to Ramesh if Ramesh also have the same favorite color red. That's the meaning here.
Okay.
So
So
I'm
in this
defining
group,
a relation.
every element, like all Mahesh, Ramesh, or Ganesh, are only having one specific favorite color. Like favorite color is like the favorite color of Ramesh is not the same as that of Ganesh.
Okay, if a person okay, I'm defining a relation. The word I'm writing here, R is related. So let's say relation is a person A is related to B if A having same favorite color. Okay, favorite color. Let's say color if A having same favorite color as B. Okay.
Okay.
So that means here
So,
this
sir,
relation is going to be reflexive because if Mahesh is there, so Mahesh liking the red color, so itself he is related, no?
Okay.
Mahesh
So,
is
sir,
itself related to itself that, okay, yeah.
suppose in numeric value, we have a certain element as 1 plus 1, or suppose to 1 plus 2, and another element is 2 plus 1. So are they also in identity relation the same thing?
Sir, with the same.
Let me finish it. Let me finish it. Okay.
Just let's stick to this example.
I am defining a relation. A person is related to another person if it having same favorite color. So I am defining. I am also giving the Mahesh favorite color is red. Okay. Ganesh Ramesh favorite color is green. Okay. Ganesh favorite color is also red. Okay. This is the relation.
Okay.
Sorry, this is the set, and relation on that set I'm defining a person is related to B if it having same favorite color. Okay. Now, is this relation is reflexive?
No.
The question is this relation is reflexive?
No, because one person.
Yes, sir. Relation on
Yeah, it is reflexive, no? Mahesh is
Yes.
related to
One
itself.
person
Mahesh.
has a.
Mahesh having yeah.
Mahesh is related to himself and also to Ganesh.
Also, yeah, that is one thing. Mahesh is related to himself, right? Because Mahesh having one. See, what is that? I'm taking okay, Mahesh. Okay, I'm now started looking another person, or it means another person means from started from him itself. So Mahesh, Ramesh, Ganesh. Okay, so what will come again? Mahesh is related to Mahesh will come because Mahesh also have the same. Now Mahesh. Now take about the Ramesh. Ramesh having green, no. Okay,
No,
it is
Ganesh.
Ganesh. Yeah, so Ganesh will come. Now
So
take
what?
the Ramesh now.
So
Sorry,
it
now take
what?
the Ramesh. Yeah.
So sir, what when we say that if this relation is reflexive, we mean to say that the element is related to itself.
Yes, that's the meaning here. That's the meaning here. Sorry,
But
let me mute to
you
all
did
first.
not take Ramesh, right?
Sorry.
I'm saying that you did not take Ramesh, right? So initially the set was not reflexive, but when you took the subset out of it and you removed Ramesh from it, that's the time when it became reflexive, no?
Yeah, if you take yes cross yes, what will come? Mahesh will come.
Yeah.
Mahesh will come. Then Mahesh, Ramesh, other will come. All possible pair will come. From
Yeah.
there, you need to collect. So Mahesh will surely come because Mahesh having this himself the red color favorite red color.
Yeah.
Similarly for others. So that means this relation is going to be a reflexive relation. That's the meaning. So let me finally use the word. Okay. Relation is said to be a relation is said to be reflexive if each element is related to itself. Okay. We take your time, you will slowly will get, okay. Slowly if you solve some more example, while solving more example, you will get. That's the meaning. Let me move on to the symmetric relation because I want to finish the function also. Okay. So symmetric relation.
Sir, in this Ganesh will be also like the same color, na?
Yeah, Ganesh. Others will. I am missed that. Not missing that. I'm now going ahead. Ganesh will come. Ramesh will come. Mahesh
Okay, sir.
Ganesh will come. Ganesh
I think
Mahesh
you
will
forgot.
come. Okay.
Yes, sir.
Yeah,
Relations
so
will.
it's clear now. It's clear, yeah.
So symmetric relation is here is let me write the definition first. R is let me tell you, R is a relation on the set S, and this relation is said to be symmetric if R, let's say if AB related to R means AB, and let me say right here, A is related to B, then this should also happen with B is also related to A. Okay. So let me mute to all first. In that case, your relation is going to be symmetric. If a relation contain, that means A comma B, this means A comma B, then this relation should also contain element B comma A. If it is there, then this relation is actually a symmetric relation. Okay. For example, here it is also true. In this relation itself, See, Mahesh, okay. See that Mahesh is related to Ganesh as because Mahesh have favorite color red and Ganesh have also. Okay, so that means Mahesh and Ganesh is related. Now see that Ganesh also related to Mahesh because Ganesh having red color favorite color, Mahesh also have. So that means this relation is actually symmetric relation.
I can give another example, sir. Like, it is like if we say that Mahesh is a sibling of Ganesh, then we can also say that Ganesh is a sibling of Mahesh.
Yes. This is another example, and this is also, this relation is actually whatever I just defined here. This relation is symmetric relation. This is all about the symmetric relation. You can differently see differently there are more example you can see that. So when we'll say a relation is symmetric, if it contain AB, then it should also contain BA. Then that relation is actually symmetric relation.
So is it symmetric relationship also have a condition like reflective that every element should be included like this in the
That condition is there, sir. Every member that what he asked.
Yes. You can say the reflexive relation is actually the symmetric relation. That's all. So every reflexive relation is a symmetric relation because if Mahesh is there, if you reverse it, still you will get Mahesh.
So,
That means every
my
for a
doubt
point
is
of
different.
information,
For
I doubt
example,
one by one.
for a point of information, you just said that every reflexive relation is a symmetric relation.
Yes.
I doubt that is true because suppose I have a set.
No. Only sorry. I missed that.
Yeah.
Oh, sorry. Every,
Yes.
not every means the identity. You can say sorry. The
Correct.
better word is say identity relation is going to be.
Correct.
Yeah, I missed that. Yeah. Because suppose you are taking a reflexive relation. Suppose S is 1, 2, and I'm defining a relation like R is 1, 1, 1, 2, and 2, 2. So this relation is going to be reflexive relation, but
not
it is not
symmetric.
symmetric. Reason is 2, 1 is not there. Is it clear? So that's the condition here needed. If AB is there, the BA is there. But in this case, see that 1, 1 is there. If you reverse it, still you will get 1, 1. So that's fine. Okay, you have 1, 2, reverse it, 2, 1. So 2, 1 is not there. So in place of that, you directly say that relation is not going to be symmetric.
Sir, so if there is one symmetric example, like there's 1, 2, and 2, 1, and there is 1, 3, but not 3, 1, is that a symmetric?
Yeah. So 1, 3 is there and 3, 1 is there. Okay, fine.
No, sir. Actually, 1, 2, and 2, 1 is there, but 1, 3 is there, but not 3, 1.
So in that case, this is not symmetric, no? Because
so
if
all
1,
the
3 is there,
elements,
then 3, 1 should be there.
so
This is the
all the
condition.
elements should have a corresponding.
Reverse. Yeah, just swap that, and if it is there, then you will say that relation is going to be symmetric. Otherwise, no.
So my doubt was similar to this. If we don't include both 1, 3 and 3, 1, but 1 and 3 are element of main set, then is it symmetric or not?
Sorry.
If I don't include both pairs, the main pair and opposite pair from the main element, for example, 1, 2, 3 are elements.
So I got your point. So what you will do? What you will do? See, if you have element, okay. Suppose you are go to the relation, take one element, okay. This is one element. Just reverse it. Okay, just reverse it. 2, 1 is there. Now, so just reverse it. You got 2, 1. Check that 2, 1 is there. If not, just say this relation is not symmetric. If it is there, just go ahead. Okay, just go to the next. Okay, you have the next 2, 1. Just reverse this 1, 2 you got. Okay, 1, 2 is there. Yes, it's already we checked. Okay, that's fine. Suppose it is not. Now take that. Go to the third element. 1, 3 is there. Also 1, 3 we have. Just reverse it. 3, 1. 3, 1 is there. No. Now say that this is not symmetric. That's all you are checking.
So it is not necessary that every element should have both pair in the relation. in case of symmetric relation.
Yes.
So, sir, basically, it's like
That's this is the mean. This is the mean checking. Okay. I don't think it's now talking about the extra. Just go one by one element, reverse it. Okay. If it is there, then say symmetric. Otherwise, no. That's all.
So, sir, in a nutshell, we must have even numbers of elements in the subset because every ordered pair will have its corresponding symmetric order pair on the other side
This
also.
is the extra thing. This is the extra thing. It can be odd also. Okay.
It can
Suppose
be
about
ordered.
1 1. Suppose about 1 1.
Oh,
I included one. So don't worry. So this is the extra thing. So don't include the
Okay.
head thing. That is one question. Maybe it could be asked.
Yes,
Okay.
sir. All right, got it, sir.
So every reflexive pair in a relation is also symmetric.
Yeah, that is correct.
Ibri?
Every reflexive pair of a relation, as in
Yes. Yes.
That
Every
is symmetric.
reflexive pair. Yes. So let's
And
move
sir,
to the transitive also. Now no question. Now no question because a good thing I told you that just take each y element and reverse it. If it is there, then it is symmetric. Otherwise, no. Now
if
no
anyone,
question will
if
be, I hope.
any, sir, any one element is not there. If it is 1 2 is there, 2 1 is there. If 1 3 is there, 3 1. If it is not there in the relation, then it is symmetric.
No, it's not.
So just now I said no. Just
Not.
now I said. So why you are? So let me go ahead now. Let me go ahead. Otherwise, we'll not finish. I have just now told you. Just go to repeat again. Just see it again. The session. I hope it will be very much clear. Let me go with the transitive. Okay. The transitive relation is. Let me write the
I have
qualification
different
here.
doubts.
Let me finish it. We'll take the doubts after ending this one. Okay. So suppose
if R is null set, then
just let me mute. Okay, we'll take your doubt later. Now,
okay.
Yeah. Suppose you have a relation. Okay, and if you have some pair. Okay, AB is there. Okay, if you have some pair AB is there. Let's say CD is there, and also if you have a pair BC is there. Okay, so let's say that means here A is related to B, C is related to D, and B is related to C. Okay, these are here is pair means this is the mean here. Okay, now see that AB is there, CD is there, and BC is there. So see that take the end one. Okay, last the second coordinate and take the first coordinate. Here is the first coordinate. What is happening? This word is saying A is related to B. Okay, here is B is related to C. This implies that A is related to C also. If such thing is happening, then you will say that that relation is transitive. Let me take an example. Let me finish it. Then your question will, I will listen your question. Let me take, for example, I am saying 1, 2. Let's say yes is a set. Okay, 1, 2, 3. Okay, I am taking a set. I am defining a relation on this set R is, let's say 1, 2. Okay, 1, 3, 2, 3. Okay, this is the relation I am defining on this set. I don't know, just say what it means there. 1 is related to 2, 1 is related to 3, 2 is related to 3. Okay, so the question is this relation is transitive or not? So how we'll check? See that 1 2 is there. Now check other element which have 2 in first coordinate. See that this have. Now this should happen. 1 3 is there. Now how it is? 1 2 is there and 2 is 3 2 3 is there. This implies 1 comma 3. 1 is related to 3. Means 1 comma 3 should be there. Check that 1 3 is there. Yes, 1 3 is
Yes,
there.
sir.
That means
Yes, sir.
now check other pair. Okay, 1 1 2 is there. Okay, 1 2 is done. Okay, 2 3 is done. We did one. Okay, next thing is 3 is there. Okay, 3 is there any in the second coordinate in the second pair? The second coordinate is T. Now check other pair which having the first coordinate is 3. No, there is no element. Okay, now go to the third element. 2 3 is there. In the second coordinate is there. Now check other which having 3 is as a first coordinate. There is no. That means we are done. This is a test, you can say. We are started testing here. I took first element. 2 is the in the second coordinate. check which having 2 as a first coordinate. Go to second, no. Go to here, yeah, it have. So now make a pair. 1 2 is there, 2 3 is there. So next pair will be 1 3 is there. Okay, just remove 2 in between and make a pair 1 3. 1 3 is there, yes, it is there, then fine. If it is not there, so actually let me say this relation is actually transitive. Okay, suppose I remove, now I am taking a relation 1 2 and 2 3. I remove this is another relation. Let's say I am saying R prime. If this relation is transitive, the reason is no. When you start investigating 1 3, sorry, 1 2 and next 2 3, but it doesn't contain now 1 is related to 2, okay, 2 is related to 3, but this implies 1 is related to 3. This implies, but it doesn't contain R. That means this R prime is not transitive. Okay, this is the mean of transitive relation. Now, for example, you can say you are having some collection of people and I'm defining a relation. A person is related to another person if it is the relation is actually friend. A person is related to another person if both person are friend. Okay, now this relation is going to be, you can say because one person is another person friend, and let's say A is a person which is a friend of B, okay, and B is a friend of C. Then in a convention way, generally in real life it is not true, but yeah, you can say A is a friend of C, you can say.
So we can
So,
take an example of siblings also.
Sorry to interrupt.
or even you can say, yeah, it is a, you can say the
In
sibling.
real life, sir,
R prime here?
can we say in real life that Satyam and Shivam are
Sir,
brothers
what is
and
R
Shivam
prime
and Sundram
here?
are brothers? Then Satyam and Sundram both will definitely be brothers.
Hello, am
Yes,
I
yes.
audible?
Yeah, you are audible. Here R is actually your this set. That's all. Okay.
R
This set is
is?
this R prime is your this set. 1, 2, and 2, 3. It contains
Oh,
2 and
okay. Okay. Any subset of R? Or this
not this is
particular
on. I am
subset?
making a sub. This is a R prime. This is a subset of this set S cross S. I am defining this is a relation. This is another relation. That's all. This is another relation.
So
Okay.
I just have a quick
Hello.
doubt over here.
Thank you.
Like for example, if we have
Hello,
six,
sir. Sir,
may I
excuse me, sir.
continue?
Yes.
Sir, I am audible, sir.
Yeah, you are audible.
Sir, I have a doubt in another topic, sir. But this topic is running so much time, sir. So can you just
Now
move
I'm
to
moving it.
another
Now
topic?
I'm not going to discuss much about the transitive relation. We are
Sir,
moving to the
before
function
that,
because somebody is here for the function. So that much enough talking.
Sir, I have a doubt in activity question 1.9
We'll
second
take
part.
it. We'll take
Second
it.
one,
We'll
sir.
take it.
Me,
We'll
sir.
take it.
Hello. Yeah, actually,
Yeah.
sir, actually, this transitive relation what we're discussing just now. Can we take only one example, please? If you can.
We'll take
just-
now. I will take
because,
example later. Okay.
like
I
I'm
will
giving
take
you,
later.
I'm giving you because I'm not understanding one relation here that it is not transitive, and like if you can please discuss, we can please discuss it. Like there's a set A. Excuse me, sir.
Sorry, function about the function. We'll take it. We'll take it. We'll take it because somebody is here only specifically for the function also. So your doubt is there. I hope it is. I will try.
Yes, sir.
Let me finish it.
I have a doubt in a function, sir.
Yeah, let me finish it. My summary. Let me finish. See, because of that, I unable to finish. But let me finish it. I have some time. Maybe I will extend the this session at least 9:15. So let
Sir,
me
what
finish about the function.
unsymmetric relation? So we also make equivalence relations.
Yeah, that is one thing I will discuss. Okay, we'll discuss.
Sir, the
equivalence.
anti-symmetric is also left, sir.
Sir, so
It is
in a
right.
function, sir, in a function, I have basically doubt in a finding a range, sir. That in question number 1.9, sir.
Okay.
For
Okay.
activity number
Okay,
1.9 and question number 2.
Let me finish it, the function definition. What is bijective? Then we'll discuss. Okay. Please everyone mute yourself. Let me finish it. I will now there will be no question. Okay. I will discuss about the antisymmetric, transitive, sorry, equivalence, and then move on to the function. So these are very quickly. What is antisymmetric relation? With an example, we can say that antisymmetric relation is nothing but it is a, see, I am defining a, let's say S is 1, 2, 3 again. Okay. I am defining a relation on this set as it is a pairwise. So let's say 1, 2 is there, 1, 3 is there. Okay. Let's say 2, 1 is there. Okay. So what is the definition of antisymmetric?
That if like
not
AB
here.
belongs to R and
AB
BA
is
also
in
belongs to R.
universe, not BA.
R is a, let me finish it. R is a relation on this set S. Then this R is said to be antisymmetric if AB is there
And BA is not there.
and here is and word and BA is okay. Okay, there are two definition you can say. Let's say, let me
Sir,
finish
BA
it.
must not there.
If AB is there and BA is there, this implies A
A
equal to
B.
B.
Yeah.
This is one definition.
Yeah.
Okay. If AB is there, then BA must be not there. This is that. There are two ways. Okay. If AB is there,
Just the opposite of symmetric.
yes. So that's why I just let me see with this example. Let me finish with the example. See that.
Sir, isn't this the same definition for asymmetric as well?
No, asymmetric says is if AB is there,
then BA must not be there.
Then BA should not be there. And
Yeah.
another thing, if AB is there, see this anti-symmetric says if AB is there, okay,
yeah,
it should not contain BA. If it is contain BA, then A equal to B should happen. This is the
It's like, sir, like in the previous example, we can just say like if Ganesh, we say Ganesh is older than Mahesh, we cannot say that Mahesh is also older than Ganesh. It's like that.
Sorry.
It's like if we
Hello,
say
sir.
like Ganesh, like A is older than C, we can't say that C is older than A.
Yes. Yes.
Sir, symmetry is like saying students in a class, and antisymmetry is like saying height of each student in a class.
Let me take you with another example. It is a pictorial form, I know it. So let me tell you that. Yeah.
Hello,
Suppose
sir.
this is a set, okay? Okay, suppose yes is I'm writing as a line, okay? This is a line. Let's say it contains this element, okay? This element. This is the, let's say this is A, B, C, D, E, F, okay? So yes cross yes, what would be yes cross yes? So that means it would be, this is yes cross yes. So sorry, the yes cross yes will be here A, B, C, D, E. So yes cross yes is going to be your, this is A comma A comma B. So this is going to be like this. So okay. So antisymmetric is include diagonal, okay, and any half of any half of.
Sir, just a small request.
This is the collection of, sorry, let me finish it.
It's not related to this. So can you take a look at the chart? I think there's a spammer in the meeting by the name of Akshay Jaikandan.
Okay, spammer. So okay.
Just take a look at the chart if you want.
So what is the issue because of him?
Just you can see for yourself some messages.
Leave it, sir.
Okay.
Continue the lecture.
We'll later see it.
Use some vulgar words in the chat.
Leave it.
Oh.
You continue.
What is the name of it? What is the name of it?
Akshay Jaikandan.
Okay. Akshay Jaikandan. Okay.
Please you all mute chat notifications, then you can not able to see messages.
Sir, what is the
Yes.
greatest common divisor of 0, 1?
Greatest common divisor. Okay, we'll take your doubt. Okay, just let me finish it. So let me finish it here. So yes cross yes, the in the antisymmetric case you are taking. So what is going to be? Let me here make it here very simple. This is, let's say, A, and B is here and C is here. Okay. So this is going to be your S. So here is going to be A. Let's say this is B and this is C is here. So it will very quickly we'll able to see that what will happen. So this is going to be AB and this is AC. Okay. This is going to be your BA and this is your BB. Here is AA and here is your BC. And this is going to be your CA, CB, and this is CC. So see that this is the collection of S crosses. This set is collection of S crosses. So now in this case, antisymmetric is nothing but you're collecting the diagonal and any. Okay. You include this diagonal and any of the, you can say this. Okay. This is the case here. You can any of the above. If you are taking subset of it, this is. So antisymmetric is actually contain the diagonal. What do you mean by that? If you are taking AB is there and BA is there, this says A equal to B. That means that this diagonal element, the reflexive, that itself related to that. That should be there. If AB is there, then AB is there and BA is there, then in that case, A equal to B should happen. For example, see that this one also.
So, sir, it is a kind of identity relation as well, no, sir?
Identity relation also included in that. And in case of
reflexive also can be.
So identity relation is only if these diagonal elements are considered, right?
Yes, identity is only the diagonal. Okay, and let me finish another thing is asymmetric is only remove this one, only below of it, below of diagonal will contain only the asymmetric element. This is all about. So antisymmetric is also include the diagonal, but asymmetric is remove that diagonal below of that those element is going to be as a asymmetric element. So that means if AB is there, then BA should not be there. Okay. So that means you can say the reflexive.
I'm able to understand. I'm able to understand the definition, but this diagonal definition is this graphical thing is a bit confusing, sir.
So if it is confusing, remove it. Okay, I'm not going to discuss it now. So let me take this example.
This relation is transitive, right? Because BB, BC, and BC is present.
So let me finish it. Let's take this example. We have 1, 2 is there, okay, and 2, 1 is there. Okay. So see that 1, 2 is there. Okay, fine. 1, 3 is there. Okay. But 2, 1 is there. Yes, 2, 1 is there. So what is the antisymmetric relation set? If AB is there and B is there, then A must equal to B. So that means what is happening here? If 1, 2 is there and see that 1, 2 is there and 2, 1 is there. So this says that A equal to B. So that means it have A 1, 2 equal to 1. No, this is not true. This is not true. 2 is not equal to 1. So in that case, this relation is going to be, this relation is not antisymmetric. Yeah.
Am I audible?
Yeah, you are audible.
Yes, sir. So there is too much confusions and doubts in these simple relations. I think if they solve the NCERT 12th NCERT questions, they will not have any problem in that.
Yeah, I think so. I think so.
Hello, sir. Can we give procedural functions of S is transitive, right?
Hello, sir.
S
Sorry.
B comma B is there, B comma C is there, so B comma C is also there. So it is transitive, right?
So why you are sticking? We are here is for the antisymmetry. You are talking about the transitive. We'll talk about. We already discussed the transitive. So why are you still talking about the transitive?
Sir, I had a doubt that if the
I just wanted to know if in this relation transitivity is
a relation can be reflexive, can be symmetric, can be transitive. Okay.
Yes, sir. But in this case, it is transitive, right? Whatever is represented in the diagonal format.
Yeah, maybe I didn't click. Maybe.
Okay.
Hello, sir.
Because B comma B is there, B comma C is there, and B comma C is also there. So
now let me take about the equivalence relation. Okay. What is equivalence relation? So antisymmetric is,
excuse me, sir. Sir, in antisymmetric relation, we can also like the relation also contains only single element of that single element
Yes,
Yeah.
this is and this suppose R is actually 1, 2. Okay.
Yeah.
So see that if it is 1, 2 or let's say 1, 3 is there. Okay.
Okay. Okay.
So this relation is actually antisymmetric. Why? The reason is 1, 2 is there. Okay, fine. But 2, 1 is, if it contain 2, 1, then it says that if it contain 2, 1, that means A equal to should 2 happen, but it doesn't contain 2, 1, so that's why it is going to be simply as a antisymmetric.
Yeah. So, but if it contains 2, 1, then I think it is not going to be antisymmetric. Yeah. Am I right?
Then if it is contained 2, 1, then it is not antisymmetric.
Yeah.
Okay, sir.
It is transitive also.
Hello, sir.
Man, why you
Sir,
are
if
speaking
it's not,
transitive,
if it is
transitive?
containing 2, 1 and not containing 3, 1, then is it a symmetric relation?
Sorry.
Sir, what I want to say that 1, 2 is there and 2, 1 is there and 1, 3 is there. But if 3, 1 is not there, so whether we consider the relation as
But
symmetric
see,
or
no,
not?
but you said 1, 2 is there and 2, 1 is there. From there itself, you can say this is not antisymmetric because 1 not equal to 2.
No, sir,
There
I'm
is
saying symmetric or not.
So not symmetric. This is not symmetric. At that point, you will say it is not. This is sorry. Oh, you are saying symmetric.
Yes, sir.
Oh, sorry. So that at this point, it is not antisymmetric if it is included 2, 1. It is if it is including 2, 1, then it is not antisymmetric. Okay. Symmetric cases will.
Hello, sir. Sir, she asked if 1, 2 and 2, 1 and 1, 3 is present, is the relation symmetric?
Yeah. So in that case,
Sir,
it
it
is
won't be
also not symmetric. The
symmetric.
reason is 1, 3 is there, but 3, 1 is not there. Okay.
Yes, sir. That's what I asked, that all the elements should have a mirror image.
Yeah. Yes.
Okay, sir. Thank you.
So
So
does
all,
that mean
so all should have mirror image. So here, even though 1, 2 and 2, 1 are present, like 1, 2 is having a mirror image of 2, 1, but still, since 1, 3 is not having a mirror image of 3, 1, we won't consider it as symmetric.
Okay. Let me
Hello,
move
sir.
on to next ahead thing.
Sir,
That
sir.
is
Sir, I have a different doubt.
your doubts will be clear. Let me finish
The
it. Let me
equivalence
finish it.
relation.
Sir, my one suggestion, sir.
My doubt is not related to the relation. I have a different doubt.
Okay. Okay. No issues. Let me finish
Can I
down.
ask?
Next thing is transitive relation. Okay, we'll take your doubt. Let me finish
Okay,
it.
okay, sir.
Transitive relation. Sorry, equivalence relation. Equivalence relation is nothing but a relation which is symmetric, reflexive, symmetric on transitive, or all three. If it is a relation which is satisfying all three conditions, then you will say that is a equivalence relation. That's all. That is only about the equivalence relation. Now,
Sir, equivalence class. Yes, equivalence
no, so
class.
there is no need to talk about the equivalence class. Okay, there is no need to, because there is in lecture there is no equivalence taught about the equivalence class, and you will never see the question on equivalence class.
Sir,
Only
but
you
in the
will see
practice
the only.
assignment, one question is there. Practice assignment, one question related to equivalence class is there.
Okay, what is that question?
It's question number 12 and 13.
Yes, sir. It includes the equivalence class.
Okay.
Sir, hello. Sir, my suggestion is that please take another class at afternoon, sir. Please.
The classes are there. Classes are enough classes there. Next class is on Sunday. Okay. The next
Yes, sir,
class
thank you.
is on Sunday. So you will see schedules in the calendar. So see what I want to suggest you. If you have better
Because
to,
it
if you have
will go fast, sir.
conceptual doubt, yeah, let me finish it. Then we'll take the conceptual doubt. Otherwise, if you have some activity
Sir,
practice,
mute all of them and continue.
let me finish it. If it is,
Yes.
if you have activity or practice doubt, you can ask. There is another session in evening also with the TAs. If you have a specific doubt on the activity and practice, in that you can ask also. So each day we have 4-hour sessions. Each day we have, and there are 4 instructor session and 4 or more than 4 instructor session and more than 4 TA sessions there. So don't worry if your doubt is not resolved here, no issue. You have Sunday, you have Monday, you have Tuesday. Each day have 4-hour session. Not here.
Excuse me,
Next day, you can ask to next day. You can ask to next day. I hope in any one of the sessions surely. So here is there. Okay, if your doubt is not resolved, you can ask your doubt in the discourse and discussion forum. If you have any one of the access you have, you ask there also.
Sir,
Yeah,
we
those
haven't been
sessions
invited
haven't
to the
started yet.
discourse as
Yeah,
of yet.
it has not been updated on the calendar yet. Those sessions haven't started. So it's a humble request if you could request the team to start those sessions.
Which sessions?
The TA sessions, which
It's
happen
already started. Yesterday
no,
it happened. Back 2 days back also happened.
so like you can ask
Wednesday
other
happened, Thursday happened, Friday is one I have session, instructor session, and evening there is TA session 6 to 8.
Okay. Has anyone else attended those sessions from the class?
Yeah,
Yeah.
the registrations have been started.
The attendance of the
Yeah.
TA session is 200, 250 like this. This is attendance. I used to there. I used to see it there.
Because it's not been
Sir,
updated
for
in
the
the
questions
TA
12
sessions,
and
sir, do you
13
mean
of
the
the
office
practice
hours?
assignment, the
Yes, office
TA
hours.
said,
Okay.
sir, for
Sir,
the
please
questions
proceed to
12 and
functions.
sir, for the questions 12 and 13 of the practice assignment, this the TA said ask the instructor.
Okay.
When the
So
doubt was asked during the TA session, they said this 12 and 13 question of practice assignment, you should talk to the instructor. So,
okay.
So, sir, if
Okay,
you are not
okay. So
discussing
on
it,
partition,
can you
no,
please?
sir. Okay, okay. On partition, let me finish the function. Then we will again move on to the partition. Okay, no issue.
Okay, sir.
After finishing this function, let me move. Then I will discuss the partition.
Sir, before moving to the functions, sir, would these graphical questions would be asked in quizzes or exams?
It may, yes, it may. So, but that is not a specific thing. No, it is totally based on the it is based on this function or relation. So I don't think it is a big issue. Yeah, the function it is a graphical. The functions are represented in the graphically. That's all. See, once you very much clear with the function, so what's your then I don't think there will be any issue with the graph.
Yes, sir. Thank you, sir.
So let me finish the function. So function is nothing but a okay. Functions are nothing but a relation. So suppose you have some relation, okay, on a set. That relation we can call function, but that function have some specific property, even more than condition. You can say see that what is a relation. Suppose you have a set, okay, you just take it the cross multi, that is called Cartesian. You took the cross product and you are taking any subset of it, and you are saying that is a relation. But when you are taking any subset, let's make some restriction while taking this subset. Okay, what is those restriction? If suppose I imposed some restriction on this relation, on this taking the subset, if it is follow that condition, that imposed condition, then that relation you can call function. That's all. So function is, you can say, some imposed condition, imposed say relation is generally you are taking any subset and saying that is a relation, and actually that is a relation. That is the definition of relation. But when you are imposing some condition on while taking that subset, then the function term came. Then the function terms came. So what is that condition? So the condition, let me tell you. So the condition is, first thing is, suppose you have set is 1, 2, 3. Okay. So what is going to be S cross S, as you know. So this is something just multiplying the pairwise. You are taking the element in pairwise. But now I am taking a relation. I am taking a subset of it. What is that condition? So I am taking a subset. Let's say 1, 2 is there. Okay. 2, 3 is there. 1, 3 is there. Okay. So this is something. So I am taking a subset of it. So see that this is a relation, fine, because any subset of Cartesian product is going to be relation. But see that what is happening here. See that. See what is here. 1 is related to 2. 2 is related to 3. 1 is related to 3. So in image form, you can say, think about the word image. What it mean that I am taking 1. I did some operation and I got 2. This is the mean. Here is relation. You can say now think as a some operation. Something I'm doing. See what I am doing here. There is a box. I am giving 1 in this box and I am getting 2. Then I am saying 1 is a word. I am saying, or either you can say now change it to. I am changing here f. F would be better to say. That is also a relation. Okay, but R and F is kind of, again you are taking the relation word always with the R. So I'm changing it. So what I'm saying 1 F 2. So that means here 1 is, just say that 1 is related to. I have some machine. I am giving here 1. I am getting 2. Okay. Again I am giving 2 in this machine and I am getting 3. Okay, that's fine. But see that again I am giving 1 again and I am getting 3 because of say, see that this is happening. I am getting 3 out. So what is happening here? When I gave 2, I got 3. But again, when I gave 1 again, I got 3. So this is a wrongness. Here is something is happening, some bad. I'm defining a relation. So what is the problem? For 1 input, they see that only 1 I am getting 2 output. So this condition is imposed on the relation. What is imposing here? It should not happen. Such thing will not. Such thing will never happen. For 1 input, here is for 1 input, single one. 1 is happening. I am giving 1 input. I am getting 2 different output, which is 2 and 3. But for the function gate, it should never happen. This is so this is not a function. Okay. This is not a function. This is one thing. The another thing is, I am taking, suppose I am filtering the relation with the different thing. What is that? 1 2 is there. Okay. 2 3 is there. Fine. So because of that, this is the problem. Okay, I remove this one. I took. Okay, this is you have. Now what is happening here? So this is a relation. Yeah, this is a subset of S cross S. Now let me make it here the same thing, machine here. Okay, I am giving 1 here and I got output as a 2. I give 2 inside and I got output 3. Our S is actually 1 comma 2 comma 3. So the relation said, sorry, this function in the function condition said, what about 3? You doesn't give 3 here. Okay. In this here, there is no 3 and some output. Here is not mentioning. You're not. I'm not. I means here is. I didn't mention this one. So this is the wrongness here. What is wrongness? For every element, you should have an image. Okay. So see that 2 conditions. One is that for every element, it should have out. So when I am giving output 3, so I didn't get any output. So for every element, it should happen. Let's say here is I am saying 2. I am getting 2 output. As output 2, when I give input 2, it give 3. Okay. So suppose suppose when I added here 3 comma 2, then in that case, this relation is going to be function. If it is suppose I didn't add it here, so this is not a function. So this relation filtered out with this condition. Okay, I am not getting 2 different output, but one thing I am missing here for the 3. I gave 3, but I didn't get output. So, but it should not happen with the case of function. So what is these 2 conditions? The first condition is for each element of the domain. See that I word I uses here. This could be represented at this relation yes to yes. So this is domain and this is codomain. Okay. So for each element of this domain, it should have image. Okay. It should, for each element of the domain, it have image. Here is the image. So this is the second element is actually called the image. The first element is called the domain element. The second coordinate is called the image element or codomain element.
It should have a unique image or one input.
Yeah,
can
so
have
uniqueness
multiple.
is, yeah, unique is I just now said, no, it should be a unique image. The first condition for each element, it should have image, and the same second, it have unique image. Okay, it should have unique image. It should be not different. So that's why separately I wrote. This is for I am getting to different output. That means you are getting not. I mean, that
So
means
in
your
this example,
is not unique.
like in this example, you said 1 is output gives it 2, 2 will
Yes.
give 3, and
Yeah.
in 3 will give 2 again. Can you scroll down a bit?
So I didn't mention
Yes,
here. I
here.
didn't mention here. I didn't mention here. Okay, this remote. So this is our F. In the case of this F, this is our F. So this F is doesn't contain no 3 input is not there. I am not
Yes.
getting output. Now let me write. Now let me filter it more. Now I'm making F. I'm making a machine which is 1, 2 is there. Okay, 2, 3 is there, and 3, 2 is there. Okay, now see it here. For each element, we have image. For 2, we have 3. For 3, we have 2. Okay. Now, for each element of the domain, we are not getting two different output. It is unique. See, it is 1, 2. Sorry, 1, 2 is there. 2 is unique. Okay. And there is no one which give the different. Then as here it is happening. For 1, we are getting 2, and 1, we are getting 3. But here is the not case. First thing is done. Second thing is that for each domain, we have yes is actually 1, 2, 3. So for each element, we have 1 here is, we have 2 here is 3. All element of the domain is covered. Okay.
Sir,
Now
so
this is function.
So sir, for input 3, can we have output 1?
Yeah, input 3. Yeah, for this machine, let me make it another function. 1, 2 is there. Okay. 2, 3 is there. So this is a function again. This is a function. No issues. This is a function.
Okay, sir.
Okay, so what do you mean by that? Even this is also a function. 1, 2 is there. Okay, 2, 2 is there, and 3, 2 is there. This is a function. For every element, we are getting output, and we are for every element we getting unique output also. Not only output, unique output. 1, 2 is there. Okay. Yeah. So one thing noted, codomain can be the same. Okay. Here you see that the codomain element. This could be the same, but in the domain part, it should not be the same. It should be always differ. Okay. This is the difference. So actually, this function is constant function, right? Because for each x, you are getting only 2. Right?
Yes, sir. Yes, sir.
This is a constant function.
Yes, sir.
Is it clear?
Yes, sir.
I hope it is very much clear that when we will say a relation is going to be function, it is a two condition. For each element, it should be image, and image should be unique. Okay. Let's see the pictorially also. What is that? So see that there is a graph thing, no? There is a graph thing. So see each element. See, this is a pairwise, no? So we can graphically. So suppose just now in the antisymmetric also I draw a graph. So let me, I am drawing a graph. Okay. Let's say this is your set S. Okay. Where the elements are, and this is S cross S. Okay. So this is 1, this is 2, and this is 3. And here is for S, this is 1, this is 1 here, this is 2 here, and this is 3. Now see that this F is I'm drawing. This is another relation. Let's say I'm saying F prime, which is 1, 2, 2, 3. The first one I'm saying the same 1, 3. Okay. This is we have F prime. Okay. Let's draw it here. How it would be 1, 2. 1, 2 is here. Okay. 2, 3. 2 and 3. Okay. And 1, 3 is here. 1 and 1. Sorry, this is 1. 1 and 3 is here. 1 and 3 is here. Sorry, this one. Okay. Let's make it as a continuous wise. What is happening? 1. Okay. Suppose this is happening.
Sir, this is not a function, right? Because one,
Yeah,
two.
so that's I'm saying pictorially I'm saying. So see that what is happening. So this, see, as I started say this is not a function. So what is happening here in the pictorial form? Let's say this is I'm kind of making like this. So in what do you by checking? Suppose you have a graph and you want to check is that graph is a function or not. So draw a vertical line. Okay, see that here is I'm drawing, see 1 1 you are getting is 3, and here is also sorry sorry I missed that. Oh, I'm making here mistake. So 1 3 sorry 1 2
Yes, sir.
and 1 3 and 2
One
3 fine. Oh, here is sorry 1 2 1 and 2 fine. Okay, 2 3
two
2
one.
oh, here is 2, no, here is 2
Sir, you
2
plotted
and
2,3 wrongly.
2 comma 3. Oh, sorry, here is 2 comma 3. This is 1 comma 3. This is 1 comma 2, and this is 1 comma 3. Oh, it is sorry,
Sir, 2,3.
sorry. Here is 1 comma 2 is here. Okay. 2 comma 3. 2 is here and 3 is here. 2
Sir,
comma 3
yes.
is here, and here is 1 comma 3.
1 comma. Yes, sir, it's correct.
Now it is correct. So let me draw it here. This is it. Now see, for the one, what is happening here? For the one, you are getting two different output. This is the same here.
Yes, sir.
This is happening. So suppose in the, let me show you now the thing is, suppose if you have a graph of a relation like this, okay, or let's say this is, okay. Suppose you have a graph of a relation this one, okay, this is a real line. So just draw this, just draw a vertical line here. So see that what it means. Let me mute to all. Okay. What is happening here?
It's
This
cutting
vertical
graph, it's
line
2 points
cut is
also.
at 2 point. What it mean that, let's say this is A here. So for A, you are getting two different output, this one and this one. So in that case, this is not a function. This relation is not a function. This is the mean. This is all about. That's why I was trying to, with this example, I was trying to explain. This is says, this example says for a single input, you are getting two different outputs. Okay, this is all about. And also you can say, for each element, you don't have the image also. There are two ways you can directly say also. There are two ways. So here is the main example, main thing. For each input, you should have unique output. This is the definition of function. Now, this is one function we done. So now let's talk about the injective function.
Sir, can you just share one more example, as I really didn't get the last one?
This one.
Yes, sir.
So this is, suppose if you have a graph, suppose in example I am saying, suppose somebody give some 4 graph, okay. So somebody is give like this, okay. Then another is just this graph, and some third graph is, let's say, this one, okay. Third graph is this one, and say that which one represent a function. So what is the thing? What you will do? Just try to draw vertically in the graph, and see that for single input, you are always get here the unique output. But for this one single input, you are getting two different output. Here is what's happening. Here is says this is A, you are getting two different outputs. This is the main here. And for this one also, it is single input, you are getting unique output. It is, so this one is function, this one is function, but this is not. This relation is not a function. This relation is a function. This relation is a.
So this is not related to parabolas and evolas, right?
So this is a parabola, you know. So parabola is parabola is actually a equation, not a function.
Yes, sir.
Yes, sir.
Is a equation,
Y
not a
square
function.
is equals to 4x.
Yes, sir. That's what my doubt was about.
Now let's move to the injective function. Injective function says for injective function is, it should be a function and with a specific mode that for example, let's say injective function, it should have a unique output. First thing was that it should be not like the constant function, no? Where I just wrote constant function. Constant function is not injective function. You are getting two different input, you are getting same output. The injective function is said, a function is said to be injective if you are giving two different input. It should not give the same output. It should be the different output. Injective means you are giving here, let's say this machine is there. Injective means you are giving here, if you are giving two different input, if this case is happening, then it is not injective. It is a function but not injective. If you are saying you are giving two different input and getting two different output, then this is an injective function. This is not. This is the mean. For different input, you are getting different output, not same output. That is called injective function. Mathematically, this is one. This is one. Let's say f is a function from set A to B, okay? And this is happening. Okay, suppose this is happening. Let's say x1 and x2 belongs to A such that, or even this is the sign, or such that f of x1 equal to f of x2. If this is happening, suppose you have function where x1 belongs to x1 and x2 an element of A with this condition. This implies if this is happening, then x1 is equal to x2. This is the mean. Or separately also, or different, if you see with the whatever given, I think for injective, if it is f is a function from set A to B, you are taking x1, x2 from the element A such that x1 not equal to x2. This implies f1 never will be equal to x2. Then f of x1 not equal to f of x2. This is two conditions. See the differences here. I took first one, then implies x1 is equal to x2. This is the same thing. Whatever this meaning is there, these two are the same meaning. This is the mean of saying to be injective. For different input, you are getting different output. This is the mean. Suppose by luckily you are saying I am getting same output, that means their input, this implies this word says by luckily I got same output. Then when you check that, this says the whatever you are getting same output, their input will be also same. This is the meaning. This tells this story and this tells this story, and both are saying the same meaning, that this function is injective.
So,
and for example, let me finish it. For example, let's say f is a function from set A to B. Okay. So suppose here is A, B, C. Okay. So injective means, let's say this is A, B, C, and here is alpha, beta, gamma. Okay. So injective means this is, you are always get, or let's say here gamma and delta also extra thing. So you are getting two different input, you are getting always different output. This is your injective. Suppose the case here is this one is happening. Okay. Suppose the case is this one.
Yes, sir.
So this is not injective, but this is injective.
So this means no even function is injective.
Sorry?
Sir, this means no even function is injective.
Even function. No, even function is not injective. That is the definition itself says the even function is not injective. So, and for now let's say surjective.
Sir, x1 is not equal to x2 is also condition of injective.
So this one. So see that this one. this two scenario is there and saying the same thing. This one is another, but saying to be the same thing for the injective. In both cases, this is, if this means, see that what is meaning here. Different input gives different output. This is the mean of definition of injective. This is true.
Yeah,
What is here? What is happening? Suppose by
Same
luckily you got same output. Suppose that function has same output you are saying. So in that case, when you check that, then you will find that, oh, their input will be also same. This is the
Same.
implying.
Yes, sir.
This is the implying. If it is same output is happening, then their input also will be the same, means equal. This is the mean. Now let me move on the surjective.
Sir,
Yeah.
could you explain it with a linear equation?
We'll take another example, but that's, I hope it is clear with the pictorial form what is happening. We'll take an example.
In a numerical form, if there are two elements 1 and 2 and their outputs are same, does that mean 1 and 2 are equal?
No, what you are checking for the injectivity, no?
Yes.
That function is not injective.
Okay. Okay.
So let me finish the on to here. Here, let's say A, B, and C is here, and here is alpha, beta, Am I audible right now?
Yes, sir.
Yes.
Yes.
Yes,
sir.
Yes.
Yes,
Okay.
sir.
Yes, sir.
Okay.
But your screen is not visible, sir. Okay.
Now
Sir.
I hope it is
Oh,
visible.
okay.
Yes.
Okay. So suppose this case is happening. So this is your domain and this is your codomain. No? This is set is F from A to B. So I said, right, this is your domain, this is your codomain. The same thing is here. So domain and codomain. So suppose this scenario is happening. So surjective means just go to the codomain, okay? Says that no element should be remain which having pre-image. That means for every element in codomain have pre-image, should have pre-image. Pre-image means this in this element. See what is happening here? It doesn't have pre-image. For the gamma or delta, we don't have pre-image. So this is not surjective. I'm taking this one. Is this surjective now? Tell me. Here is delta.
Yes, sir.
No, sir.
It's again not surjective because for delta we don't have pre-image.
No, sir, this is not.
Yes, sir.
Sorry?
This is not surjective, sir.
This is not surjective. Yeah, this is injective, but not surjective. So for delta, we don't have pre-image. So this is again not surjective. Similarly, this is also not surjective. Now let me make it another example. Let's say A, B, and C is here. This function is from A to B. Here is, let's say, alpha, and this is beta. Okay, and the scenario is this one. Now see that. Now tell me, is this surjective? So
Yes,
see that
yes,
Yes, sir.
codomain is, this is a domain, this is codomain. In codomain, for each element, at least we have a pre-image. See that for beta also we have, and for alpha we have also. Yeah, it is clear that it have two pre-images, but
Sir,
yeah, at
but,
least it have pre-image.
Sir, but alpha has two pre-images.
Yeah, alpha have pre-image, but what is the definition for surjective? Surjective says at least it have pre-image. May come at least one it have. Okay, this is the mean. It may be more than 2, it may be 2, but it should have at least one pre-image. This is the mean. So that means this is a surjective function. Okay, and now the bijective means if a function is both surjective and injective and surjective, then your function is bijective. That's all.
Sir, can you take another example? Any
Now let me
question
take a real life example. Let's say I'm saying fx is equal to x square. This function is from R to R. Okay. I'm saying this is a function. Okay. Now fx is equal to x square. Now tell me, is this function is injective?
No, sir.
No. Reason is why? For 1 you will get, sorry, for 2, let's say for 2 input you will get 4. For -2 you will also get 4. So 2 and -2, two different input, but you are getting same output. So this is not injective. Okay. Is this surjective?
Yes.
No.
Yes, sir.
Yes.
No, it is not surjective.
No,
Why
sir.
the reason is?
No, sir.
Take this is your codomain, no? Take -2. Okay. If you have any sorry, let me mute. Let to mute all. Okay. For -2, do you have any pre-image? Do you have any real number which give as a square which give -2? No.
No, sir. No.
So this function is not surjective also. Let me take another
Sir,
example.
what if the function was from n to n instead of R to R?
Sir, so in
Will it
this
be
case, all the
injective?
real
Sir,
numbers
will it
are
be
positive.
surjective?
Let me take
a
with this function the same n to n, but f of n, and n is actually, let's say r even x is equal to x square. Now tell me, is this function is injective?
Yes, sir.
No.
No.
No,
Yeah,
no, sir. Sorry,
No,
sir.
sir.
No,
No, it won't be an injective function.
No, this is actually injective, no?
Because of
This
the
is
we don't
injective
have any
function
pre.
because we are only taking positive values.
Yes, the reason is you can actually do by searching it. How you will do also. Let's assume I want to do is this injective or not. Okay. So let's assume that I am taking x1 and x2 from the natural number. Okay. As the definition, we'll go with the definition. So suppose x1, x2 from the natural number. Okay. And by luckily, as I used to say, let me mute to all. But as I used to say, let me mute. And by luckily, I said, okay, x1 is equal to f of x1 is equal to x2. Then I have to anyhow reach to x1 is equal to x2. Let's say, not imply, let's say this is the condition. So that means this says x1 square is equal to x2 square. Okay. And see, these all are, you are dealing with the natural number. That means if you take the square root of both sides, you will always get a what? X1.
X1 equal to X2.
Right? So see that what is happening here. I said by luckily you said that, okay, I am getting f of x1 is equal to f of x2. But when I solve it, when I reach to conclusion, I got, oh, x1 is equal to x2. In that case, yes, this is your injective function. This is the actually process to say that a function is injective. This is actually process to solve to reaching that, oh, is this function is injective or not. This is actually the reason. This is actually the process to solve it, to get that. Now for surjectivity, you can think that 5. Do you have any number which have square 5? No, there is no number in the two codomain, in the domain, because domain is a natural number. So this is not a surjective. Let me now the same example. Let me suppose this is n. Okay. No, this is R.
Sir, this x square from n to n is not surjective, right?
Yeah, n to n is not surjective. I am making this one the same, but the domain is R, but codomain is n. Is this function is Injective, surjective. Can you tell me what is this?
Sir, this surjective.
This is surjective.
But not injective, sir.
But not injective. The reason is for -2 you will get 4. Yeah, it is the natural number. For 2 also will get 4. Yeah, natural number. So for different input you are getting same output. So this is not injective. But what about the surjective?
Yes, it is.
It is surjective. It is an
It is
onto function.
surjective if you take any number. If you take any number, let's say I'm taking a natural number a from a. Take the square root of a, right? If take square root of a, okay? So square root of a is actually will be a real number, right? It will be a real number. There is no issue because a is positive. This is a real number. That's why actually we have one. So if you take the root of square of a whole square means f of root of a, that means root of a whole square. This is a, right? From codomain I took a and in domain I got root a. That means this function is actually surjective. So see that what is happening here. What is happening here? When you are changing the domain and codomain with the same function, sometime it become injective, sometime it becomes surjective, sometime it become only injective, sometime it will become only surjective. Right?
But sir, in natural number, not if it's a natural number is the codomain, then it and then the range and codomain is equal or not, sir, in this.
Yeah, so actually this is the range is actually equal to codomain. This is happening. No. Sorry.
The range is not equal to codomain, sir, because
No. Sorry.
6 is there.
No. That is correct. That means it is correct. It is correct. What is here codomain?
Codomain is all natural numbers. If we consider from 0.
One thing I am missing here. One thing I just missed that in the hurry, that this function is not actually. This is not a function. I just missed it. In the hurry, I just quickly showed that this is happening, but I missed that. What I'm missing here? Actually, this is not a function. Can you tell me why the reason is?
Because for every value of a domain, we will have 2 values of the codomain.
No, this is not a reason.
So can I?
Yes.
So because in the negative part, we also get the same, and the positive also we got the same.
No, that is also not reason. Can you give?
Sir, we are getting the same output for a single input.
No, the reason is this is no, not this is not. The reason is what about suppose you are taking 1.2. This is a real number, or let's say 1/2, and I'm making a square of it. You are getting 1/4.
Yes, which is a decimal.
1/4 is natural number.
No, 1/4 is rational number.
Sir, there should be no element left in domain.
Yeah, in the codomain. No, in the codomain you are not getting image. And I said right, it should have image. For each element, it should have image. What about 1/2? It don't have image.
Right, got it. Yeah.
That's why it is not a function. I missed that in hurry. Actually, this is not a function, but in the case of showing to be surjective, I just quickly took in that. This is my fault, but actually this is not a function.
Okay, sir, we understand.
Got it? The reason is
Okay, sir, got it.
1/2 is an element of the domain, but you are not getting output of it.
Sir, 1/2 is equal to 0.5 is alright, sir.
So 1/2 is 1/2. When you square it, you are getting 1/4, and 1/4 is not a natural number.
Sir, 1/2 is equal to 0.5. Is it correct?
Yes.
Sir.
So that's I almost think I have covered about the injective surjectivity relation. I tried how much possible. Now I will try to take your doubts. So now let me know your doubts, or I will say let me close it. Today evening is now it's almost 10. I took 4 hours.
One simple doubt. What is
Sir, I have one simple doubt, sir.
0 and 1. Greatest common divisor.
2 questions, sir.
Sir,
Okay.
I have
What is the
only a
greatest
single
common
question.
divisor of 0 and 1?
Let me raise your hand one by one. Let me take your doubts very quickly. Let me see that how it possibly, because it's almost 3 hour session. Okay, I am
Simple
suggesting
question,
if
sir. What is
you have
greatest common
time,
divisor of
if
0 and 1?
you don't have, let me finish. If you don't have time, you can ask in evening also. TS session is there, or I will try to finish your doubts till here. But let's see that how it will go. Or the reason is next day we have also session. Today evening we have also session. On Sunday we have also session.
Sir, where is the session, sir?
In the calendar you can see.
Sir, I just want to know what is the GCD of 0 and 1.
Okay. Okay, just 1 minute. So this is the calendar, no? This is the schedule. If you see that today is 9.
Only morning session is there, sir.
So today instructive session is in morning, but today evening there is one TA session, right? Open session by TA.
Yes, it is there.
Similarly, in the Saturday also you can see a session which is 6 to 8, which is TA, which is taken by TA. But if you see that on Sunday, there is an instructor session which is, this is Maths 2 session.
In our calendar, it's not updated, sir.
So just update your calendar. No, once you open your calendar, okay, just go to, what is the process you can do? Just, okay, you are here, you are in portal, just open your calendar here. Okay, let me open it here. Here is important link. In the calendar, in this course introduction, you will get your just a minute. General instruction important link.
Sir, it is in the about the course.
About, sir, Max 1 calendar. Discussion 4 minutes. Okay.
Yeah, this is Maths 1 calendar. So if you click on here, so this is the reflecting for me. If it is in your, it is not showing, no. So there is a message will pop out that add something. There will be a link will given and add something. What is used? Once you add that, your calendar will be updated with the new updation. Okay.
Hello, sir.
Yes.
Sir, we are getting this is the date of 9 today, but we are getting, you have in calendar you have 4 sessions, but we are getting only 3 sessions.
No. So this is the different courses also. For me, I have subscribed for Maths 2 also. So because of that, I'm getting. Okay. So don't worry.
Excuse me, sir.
Yes.
Sir, please let me know the GCD of 0 and 1, sir.
Okay. So for 0, 1, anybody can unmute and then what is going to be GCD?
Zero.
One,
sir, maybe.
One.
One, sir.
Zero.
Zero, sir. Zero.
Zero.
One.
Zero, sir. There is no
Nobody
common
says
divisor.
2. Nobody says 2. Why?
Sir, it can be any number, I guess.
No, what do you mean by GCD, greatest common divisor, right?
Divisor. Yes.
So why you are not thinking about 2?
Because 1 cannot be divided by 2.
Finite.
No.
Sir, divisor means is the
No.
the divisor means it should be the perfect fact. It should be the factor also, na?
What do you mean by this GCD, greatest common
Common
divisor?
divisor.
That means it should divide an maximum number, means the greatest number. What do you mean? How you will collect the GCD as you used to collect? How you will get, like for 0, what is going to be the divisors? All natural numbers, you can say. All natural numbers are divisor except 0, you can say. That means you can say in the set form, you can write this is going to be a divisor, right?
Yes,
what
sir.
about 2? What is going to be the divisor of 2? 1 and 2. Only these 2, right?
Yes,
and what
sir.
is going to be your common divisor? And in these 2, what is going to be your common divisor?
One, sir.
1, 2.
2,
And what
3.
is going to be the greatest common now?
It's 2.
2. So what
2.
is going to be a GCD for 0 and 2?
It's 2.
2, sir.
So
Okay.
for 0 and 1, it is 1.
0 and 1, it will be.
Okay, thank you, sir.
Okay, let me now we'll go to by the race. Biswajit Roy, what's your doubt?
Sir, evening also you will be there, right, sir?
Yes, evening also there.
Okay, sir. Thank
Who
you. Sir.
wants to ask there, you can ask there. Otherwise, who wants to be here, you can quickly do that. I will try to finish very quickly
Sir,
because we
please
have
pass
also
on the
session.
message to the TAs to solve
Sir,
question
I have a
number
doubt in
12
one
and
question,
13
sir.
of
In
practice
activity
assignment.
question, sir.
Sorry?
Sir,
So
I have a
please
doubt
pass
in
the
activity
message to
question, sir.
the
Sorry, somebody is saying some message. Okay, what you are doing? What you are saying?
sir, in the TA session, there was this question 12 and 13 in practice assignment. They said ask the instructor about it.
Okay.
But sir, now you're saying ask the TA to do it. So
Okay,
can you
let
please
me
pass
open
on
it.
the
Okay, if your doubt is that, okay, let me open it and see that what is going to be that solution. Okay, no issue. If he said for the instructor session, let me take first, okay, because if TS is not solving, let me open and solve it.
practice assignment 12, 13. It's a lengthy question, sir.
12.
Yeah, this one only. The questions begin from 12, but this is the question for 12.
Okay. Okay, so for this one, actually this question have removed. I again have to say for removing. This is one error, I think. Actually, in this question, this doesn't contain any error, but it is a lengthy question. So, and the solution, if while solving, see, while telling it will take long time. So once I will upload the solution, it will very much clear. Otherwise, see, this question is going to be removed. Last time it have removed, but now still is there. The reason it's a very long question to solve it.
Yes,
so
sir.
let me upload the solution. You can see there, or it will be removed from this.
Where will the solution be updated, sir?
Yeah, I said already to the operational team, but I don't know why they didn't upload it. It will be uploaded by today evening or today afternoon. I will say it will be uploaded.
Sir, it is
It will be
uploaded
uploaded in the
in the
discussion
YouTube
forum,
playlist.
sir.
There it is there.
Sorry?
It is uploaded.
Sir, it is in the playlist. The solution is there.
Also in the playlist, you can see the solution of this question. Yeah, I
Sir,
think so.
Still, it was
yes, sir.
difficult
Sir,
to
I have a
understand.
doubt. Sir, practice
Sir,
assignment
where?
has been removed.
Sorry, one by one. Sorry.
Practice assignment 2 has been removed, and I have doubt.
Yeah,
on
that is also, see, that is a the error from the operational team. I said them to remove, but they took 4 to 5 days. Only one practice assignment is there. Okay, only one
Okay, sir.
practice assignment there. So don't worry.
Sir, where
Now whatever
solution?
it's showing here, it will be there, but this question will be also removed. But if you want to see the solution, it is in the playlist and very much explained. Just see that, and it will be very much clear to you.
Thank you, sir.
What is the name for the video for this question itself?
Sir,
let me open it. Just a minute. Let me open it. Let me show you if somebody's have doubt with this. Let me open with the playlist. Where is the playlist? Here is showing. Discussion forum.
Sir, in the Max 1 playlist in the YouTube, that for all the videos have been uploaded in the YouTube. That's the
In the
playlist.
qualifier portal, there is no playlist.
It is under
I'm
the
sharing it.
section.
Where is that? No. I don't want. I want playlist here. Is there? Where is the playlist?
General instruction.
In general instruction. Oh, introductory video. General instruction is this one, no? This is introductory video. General. Here is document timeline, grading document, below course specific, maths and calendar. Calendars are there. Calendars are here. Math. Why this is so? This from this get course announcement.
Sir, just open any video and you can go to the channel and it will
Yeah, I
just
can go,
create
but there should be a playlist. How many times? Okay, no issues. The playlist will be uploaded. It should be all the videos in the single YouTube playlist. It should be there. In
For us,
the
it is available, sir. Playlist is available.
for Tom portal, no? For Tom student. It is a qualifier portal is there. So for a qualifier, this is a different portal is there. And in this portal, we don't have playlist. It will be updated. Okay. I'm just noting here.
how should we notify
sir.
via email?
Sir,
Yes.
I have a doubt in question 5th of 1.9.
Okay, 1 minute. Okay, so let me go with the raised hand first. Otherwise, somebody will come and say that, oh, you are not taking. So Biswajit, I don't think have doubt. Okay. Prabhat Tripathi.
Yeah, yes, sir.
Okay, what's your doubt?
Activity 1.9.
Okay, which question number?
Question 5. Sir, actually, I have a doubt on behalf of my friend. He is also raising his hand, but he said that you were not paying attention to him. So that's why I asked
Okay,
it.
no issues. Yeah, actually, because of I can't. This
Yeah,
is the kind
yes.
of summary. That's why.
So, sir,
yeah.
Rishabh Parik it is. So, sir, he will be asking the question.
Okay, what is yeah, Rishabh? Sorry for that. Yeah, hello. Am I audible?
So I think he can't speak, but he asked the same question from
Yeah,
me.
Prabhat, you can tell what's his doubt.
Sir,
I'm
his
very
doubt was that he didn't. Sir, he was asking if the first option was injective or not. As
Okay, the first
total set
option is
it was.
injective or not. Okay.
Yeah, yes, sir.
So okay, just now we discussed with the function. Can you check? This is from real number. Okay, this is from the domain is of this function is real number. So can you think about -1 and 1? Okay, just a minute. This is which of the following function is our injective? Okay, so you can check with this one also. What we did now, we have, let me open it. We have fx is equal to root over 10 minus x. We have this function, and this function is from R2, I think, R. Okay. No, this domain of the function is, what is going to be domain for this function? Can anybody tell?
Less than or equal to 10. X is less than equal to 10.
X is less than or equal to 10, where x belongs to R. Okay, this is going to be your domain. Now, what about in this domain? It is going to be injective? How we will check this, or how we will check that is this function is injective?
So it is
f of x1 is equal to f of x2.
Again, the same process. Suppose there is x1, x2 with this condition, right? Yeah. Now that means 10 of root over 10 10 minus x1 equal to root over 10 minus x2. Okay. Now I need to solve it. Solve this. Take the square of root of both sides. This is going to be 10 minus x1 is equal to 10 minus x2. Now you can cancel out 10. This is going to be x1 is equal to x2. That means once you assume that their output is same, but you got in their domain, in that domain, you got input is also same. That means your function is injective. Is it clear, Prabhat?
Yeah, yes, sir.
Okay. I hope he may
Excuse me, sir.
Yes.
Sir, if we have to check whether it is surjective or not, then how we are
So
to
for
calculate
surjective, you have to take away. So for surjective, there is no such process. You have to think, and at least you have to reach at least you have to find a single element from the codomain which don't have pre-image. If it is not there, so for surjective, there is no such process. Actually, surjective is much thinking. Okay. So analyzing the domain, sorry, codomain, and then talking about the pre-image. Okay.
Okay.
So let me go with the next. Prabhat is done.
Sir,
Yeah,
can I ask?
Let me go with the after Prabhat, who is there? Where is that? Biswajit Prabhat. Okay. A161. Who is the name? What is your good name?
Good morning, sir. Shirish
Good
Pandey
morning.
this side.
Yes.
Sir, in activity 8, question number 7, the first option is an equivalence relation partitions a set. Sir, what does this mean?
Yeah, the partition thing is remain. So which question number? I think the 7th question.
Question number 7.
Yes. So what do you mean by, let me finish with the somebody's, that's why I want to go with the activity. Somebody surely have this doubt. So what do you mean by this partition? So let me open it. So what is that partition? Any place is there? Suppose, okay. Suppose you have a set. Okay. Suppose you have a set, yes. Okay. This is the some collection of element. Let's say I'm making collection. This is a collection of fish, some finite fish. This is some. This is a collection of. Okay. This is a collection of. So this set is actually collection of. Okay. Some this. So suppose this numbers of fishes. Okay. This number of fishes. This number of flowers. This number of dogs is there. Okay. So see that what is happening. So this set is actually some collection of some element. I don't know. This is a mess up set. Fishes is there. Okay. Fish is there. Flower is there. Dog is there. Let's say lion is there. Some collection. I just randomly collected some animals and put in the set. Okay. This is the set. Now I am defining a relation on that set. The relation is R is saying to be the same Prajati. What do you mean? What do you mean in English? You will say Prajati. Same
species.
Okay. In the same species, you just word two objects are related if they are in the same species. Okay. If they have of the same species. So now tell me that is this relation is reflexive? Yes, it is, because dog is related itself. Each fish is related, is going flower is going to be related. Okay. Now check for symmetricity. Dog with the different dog is related, and different dog is related. So actually this is going to be symmetric. Now check for transitivity. Dog is dog related, fine. And different dog is related to different dog. So yeah, it is going to be transitive because of same species there. But dog and flower is not going to be related. The reason is if dog and flower is related, you are saying it will never happen. It will never happen with this relation if you take the relation on this set. So that means what is happening here? You are making a partition. This is the mean of partition. You have some collection. When I define a relation, this relation is become equivalence relation. Now see that what is happening. Dogs are in one set. Okay. In this flowers in one set, lions, elephants are in the same species are come to the in a different. So partition is actually this is one partition. This is another partition. This is another partition. Another partition. These are different partition because of this only one relation. So partition is nothing but a set, but having the same type of element. See that this is a partition. Okay, with the same type of element. Fish. This is the same type of element flower. This is the same type of element lion or dog. So this is the partition. I am partitioned this set in the different sets which have same property. Is it clear? Is it clear?
Yes, sir. Sir, can you please give some other example which has numbers?
So within the partition, they are equivalent relation.
Yes, within the partition, see that within the partition, they have equivalence relation, right? This is happening. And this is the partition is happening. So partition is nothing but a set. But in that set, if you check that the relation, it is a equivalence relation. Partition is a making a collection of subset, okay, collection of some element. And when you are checking the relation in this set, actually the relation is an equivalence relation in that set. And because of that is making a partition. Is it clear? This is the partition.
Yes, sir.
And this is the mean of equivalence give a partition.
Sir, and you said question number 12 and 13 are deleted from practice assignment. So will similar question come in qualifiers?
No. It is a very
Quiz one.
long. If you see the solution of video, it will actually explain at least 5 or 8 minutes. So no such question will not see. Qualifier or even in credit or in quizzes, see 1 hour we have. So why such things will happen? It a tougher question. That is the one toughest question I will say. Okay, so don't worry with that. Okay, so this is one thing. So I hope now it is clear. If you see the option, I hope you can solve this.
Yes, sir.
Okay. Now go to the next. Who's the next? It is now 12. Okay. Sneha.
Yes, sir. Actually, the math schedule got removed from my calendar, and I'm trying to add it again, but it's showing an error. It is saying that cannot add the calendar. Check the URL. So, is there something I can do about this?
When suppose so see when you go with when you click here and go to the calendar, when you click on the calendar, some message will pop out. Just add to there. There is one add in the box will written. If you click on there, it will add it in your calendar. Okay.
I added it, but it got removed, and now it's not getting added. Like I have tried the ways you are mentioning. I've already tried that, but it's not happening.
Somebody is here. Somebody is here.
Google.
Can tell her how it would be now recover.
Just open in Google Chrome. Just write Google Calendar.
Okay. Then after.
Then go to settings.
Okay.
Then there comes a pop-up subscribe to calendar.
Okay. So the thing is, Sneha.
Copy the URL in this dashboard and paste it here.
Okay. So Sneha, what you can do? Either you can see on YouTube that how to add a calendar. Okay. And just click on link and you can add. So this is one thing he is saying. I hope.
It might be possible that she might have added it, but the check mark it's not clicked on. Like
I checked that it's not there.
The check mark wasn't even there.
Yeah, I know about the check mark thing.
If you have Google Calendar app in mobile phone, just first uninstall it.
Okay.
Then go to Google Chrome. Write Google Calendar and then go to settings. After go to settings, then go to subscribe to calendar. Copy the link from the dashboard.
Okay.
And paste there.
I don't think you can actually delete Google Calendar.
Sir, session is over, right, sir?
Yeah, session is to see asked. That's why I just
only the personal doubts. Only people are asking personal doubt, right?
Okay,
sir?
okay.
So we can leave it out.
I just asked the suggestion. Maybe because I don't know how to subscribe. Otherwise, Sneha, can you try once? Has the
sir, we can leave, right, sir?
Yeah, if you don't have, you can leave.
I mean, you are clearing the personal doubts, right?
No, not personal doubt. Somebody is raised hand. I am just trying to finish that, and we'll close the session.
Sir, are we going to
Thank you,
cover any further topics?
Thank you, sir.
Sir, are we going to cover any further topics?
No, now I know there is no. I just try to cover your doubts. Otherwise, there will no further doubts. It's already more than 3 hours.
Sir, can I ask, sir? A1910.
Yeah. You are the next. Yes.
Sir, my clarification was you told before antisymmetric relations. In that, I have clarification that is reflexive and identity relations are subsets of antisymmetric.
Reflexive and reflexive and identity. So identity you can say is it could be so actually identity is going to be antisymmetric, right? Because when you are taking when you are taking A is related to B, B is related to A, then A equal to B, it is actually. So identity is going to be, but not sure about the reflexive. So each reflexive cannot be, but only the identity element can be the antisymmetric.
Sir, can you tell the difference between identity and reflexive relations?
So the difference between identity relation and reflexive is that identity relation contain only this much element. Let's say S is 1, 2. Okay. So 1, 1 and 2, 2. But so this is an identity relation, but 1, 1, 1, 2, and 1, 1, 2, 2, and 1, 2. So this relation is reflex, right? Because 1, 1 and 2, 2 is there. Extra 1, 2 is there. So reflexive is identity contain only 1, 1 and 2, 2. But reflexive contain more than that. So this is the difference. So identity, you can say subset of reflexive. This is the difference.
Okay, sir.
Okay.
The next question was, yes, sir. Practice assignment 8th question, sir.
Okay. Just a minute. It is the 8 questions. Okay, we have this one. Okay, what is your doubt here?
In that symmetric relation, why can't it be symmetric relation, sir?
Second option.
Why it is not symmetric? Whatever we have, okay, we have a, b or non-zero integers. And a, b is, and this is an integer. A and b are even non-zero integers. Sorry, and a divided by b, a by b is an integer. So is this relation is reflexive? Oh, sorry, you are saying symmetric, no?
Yes, sir. The answer is 1 and 3.
Okay, so why it is not symmetric? Can you think about 1 and 3? 1, 3.
Yes, sir. If A is 1, B is 3.
Okay.
Or
Or you can think about, sorry, or you think about 3, 1. Sorry, yes, take 3, 1. 3, 1, 3 by 1 is going to be integer, right?
Integer, yes, sir.
But 1, 3, it
No,
is going
sir.
to be 1 by 3.
No.
It is not an integer, right?
Yes,
1,
sir.
3, it is going to be 1 by 3. It is not an integer. So why it is? So it is. That's why it is not an symmetric.
Sir, sir.
Yeah.
Sir, it is saying even non-zero integers.
Even non. So okay, even non-zero. So take even any in place of 1, 3. Just take even non-zero. Let's take 2, 6, and about what about sorry 6, 2. What about 6, 2? 6, 2
I got
gives
it, sir.
Got it, right? Even you can think about the even, it will work. Sorry, I just took for 1, 3, that is odd. But you can think for even also, it will work. We just know whatever we discuss. Okay, so let me go with the next one very quickly. Okay, Syed Arman Ali, what's your doubt?
Yes, sir. Good morning.
Good morning. What's your doubt, Syed?
Sir, I have a doubt in activity question 6 in the last question.
6. Okay. 6, 6,
1.6.
Okay. In the last question, what's your doubt there?
Sir, it is written about cardinality.
Mm-hmm.
So how can I find in this question about cardinality?
So possible. So see, it is asking for the possible cardinality of that set, and it says that number of subset of A is 56 more than number of subset of B. You can assume, no? This is you can form an equation. Let me mute to all. Okay. How you can assume? Suppose the cardinality of the set is X. Okay. Now you can solve. Assuming to be X, you can add, subtract whatever the condition is saying here. Or you can assume the cardinality of subset of B is X. Okay. So what is going to be the cardinality of A now? X plus 56. Let me mute to all. Who is making this? Please mute yourself. Syed, I think from your side. Okay. Sorry. Oh. So what is that? You can assume that B is going to be, just assume the subset, the cardinality of set or number of elements or number of subset of the B is X, and then what is going to be number of subset in A is X plus 56. Now if you solve something is there, okay, what is the two finite subset AB such that the total number of subset of A is 56 more than the total number of subset of B. 56 more than the total. So I just assume that, okay, X is going to be 56. So subset of A is going to be X plus 56. So what is the what are the cardinality of A and B respectively? Or either just you can do, right? If you have assume A is, by option wise you can solve it. By option wise. Assume A is 3, 6 and B is 3. And find the total subset. It is going to
Can
be
we
2 power
check
6.
by taking option one by one?
One by one option and check that which give the difference 56. That's all.
So even I had the same question. There is no
Sir,
difference.
if number of element in A is X, then subset is 2 raised to power X.
Yes.
Then, okay.
So something, see, option wise, if you go option wise also and find the subsets, okay, and then see the differences, and if you so differences give 56, okay, cardinality of the power set, you mean see here, say. So if you give the differences is 56, then it is going to be that your correct option.
Sir, if we have to calculate manually,
no
then how
option
should we do?
So manually, maybe because there are more than some. So see, here why it is the option is given. There are another subset having more element. Maybe also give the difference between these two is 56. So correct answer is difficult to find that. That's why if you go option Y, that would be good.
Okay. Sir, I have another doubt in activity question 1.7.
So somebody
Sir,
have this
in this
doubt
also
here
no-
with the same question. Who is here?
No, sir, it's clear.
Okay. What's again? What is doubt, sir?
1.7.
Okay. Which question number?
First, do we have to draw a Venn diagram?
It's totally up to you. If you solve with the Venn diagram, it's very much clear. It will be very much clear to you.
Sir, can you please draw a Venn diagram? Actually, I have some little bit problem.
So it is, if you are able to know the concept, I will suggest you that try once again. If you not know the concept, then so I will suggest you just go to see, because of time being I am saying. Can you ask this question at TS? They will surely solve it. I'm sure. Because this is one thing that see, you are missing some point, some number. You are missing some number. You are making numerically wrongness. So that is I am leaving to you now.
Okay, sir.
Okay. Otherwise, also ask in Discord. They will surely give you a correct numeric also.
Yeah. Actually, I
Sir,
have.
in last question, no option is satisfying the condition.
No, it surely should satisfy. Okay, the answers are correct actually. Okay, let me go to the next. Sad is done to Subhranshu. What? Hi, Subhranshu. What's your doubt?
Yes, sir.
Yeah, what's your doubt?
My doubt, sir, can I find GCD of 0 and 6,
Your
7?
voice is breaking, Subhranshu. Subhranshu.
Hello, sir.
Your still mic is breaking. So please mute somebody. I think. Okay. Let me mute to all. Okay. Now, Subhranshu, you can mute it till.
Hello, sir.
Yes.
Am I audible?
Yes, you are audible.
Sir, in practice assignment 1, question number 2.
Mm-hmm. There is not one, only one practice assignment is there. Only practice.
Yes.
Okay. In this practice assignment.
Question number 2.
Question number 2. Okay. What's your doubt here?
Sir, here A is a set which is the natural number less than 6, whose GCD is GCD with 6 is 1. So here, in set A, 0 is 0 does not belongs to A, because GCD of 0 and 6 we cannot find.
No, GCD of 0 and 6 you can find. Just now we discussed. You were there when we were discussing? GCD of 0 and 2? GCD of 0 and 2? What is going to be GCD for this one?
1.
No, actually 2. Okay. So please, I will say again to rewatch it once, because of the time being, I am very quickly and try to deal. Okay.
Okay, sir.
Yeah.
One more doubt, sir. Hello.
Okay.
Sir, there was a practice assignment 1.1 and 1.2, which is deleted already.
Yes.
So, a question is M union N equal to M intersection N.
Okay.
So, what is this condition? Like M or N are empty set. In this option, this option is correct or not?
Yeah, for empathy, it will correct.
But in answer, this is wrong.
No, so I'm not sure about it, but that should be never, because if you take the two empathy set, if you take a union, it will be empathy. If you take intersection, still it will be empathy. Okay. Okay, so
Yeah, I have a doubt.
yes, let me go with Subhranshu. Next one.
Sir, is optional. Option A, M or N is empty set. Option B equal to M equal to N. Option C equal to cardinality of M minus N equal to 0. And last option was N is a proper set of
So
proper set
I will suggesting you how you will solve. Okay, just take some example as he's saying. Okay, as option wise, he's saying cardinality of this is this, this is this. As he's suggesting some, as option is suggesting, take some example on based on that and check which one is going to be M intersection M and M union N is giving. Okay, this is the process you need to solve. Okay, Manish, what is your doubt, Manish?
If R is null set, then comment on whether it is reflexive or symmetric or transitive.
If somebody is, let me mute to all. Manish, now Manish, you can unmute or tell.
Hello, sir.
From your side, it is coming? Okay.
No, sir.
Who is there who is making noise? Because of that, I am unable to listen you. No, only you are there. Okay, so what's your doubt? He is the Manish next one. Okay, Manish, Kumar, what's your doubt?
Sir, if R is null set, then comment on whether it is reflexive or symmetric or transitive.
So don't worry. Without defining the relation, you cannot comment anything. Okay. On and one thing and second thing, when you are defining a relation, your set should be non-empty. Okay.
Okay.
Yes. Now Pari is next. What's your doubt, Pari? I think Pari is
My
there.
doubt is in activity 9, question 6.
Activity 9, question number 6. Okay, just. What's your doubt? Okay, what's your doubt here?
This question.
The question is, see how the question is saying if you have a function which is defined like this ax plus b, okay, and the a is writing as a equal to 0, b is the integers, set of integers, okay. So what it means that you take an a equal to 0, substitute here 0, and b equal to takes any integer. It is saying you take any integer and check that which is going to be injective or bijective. That's the meaning here. Got it?
Thank you, sir. Yes.
Now let me go with the next. I think Sastika. Okay, Sastika is there. Sastika.
Hello, sir.
Yeah, hi, Sastika.
Sir, I have doubt in 1.6 one, sir. Exercise
1.6. 1.10. Please, everyone, mute yourself. Let me mute. Swastika, what's your doubt? Sorry, which question number?
6th one, sir.
Okay, 6th one is here. Okay. Is asking about the R is reflexive, reflexive, symmetric. So, see, you have just now, if you change, Swastika, you were there when we were discussing about reflective, transitive, symmetric.
Yes, sir.
So if you change, if you are getting the word with this Snell word, Fox word, so can you give unique number? Snell, let's say 1, Box 2, Bird, okay, 3 and Frog 4, okay. And now accordingly just substitute here number and whatever we just now said, right? Reflexive, how we'll check reflexive? 1 1s, 2 2, 3 3 4 should be there. Or for symmetricity, if 1 2 is there, then 2 1 should be there. For transitivity, 1 2 is there, 2 3 is there, 1 3 should be there. So if you go with that also, you can easily check, right? If you are confusing with the these words, just give the unique numbers, please, and substitute here also and check whatever we just now discussed. That is very much easily can be done.
Okay, sir. Thank you.
Yes, because I hope we spent much time on that to discussing at least reflective, symmetric, and transitive. Okay, the next one is what is done? Sastika is done. Rishabh Parik, I think. Yeah, Rishabh. Yes, Rishabh.
Hello, sir.
Yeah, hi, Rishabh.
Hello, sir.
Yes.
Sir, actually, he's having some problem with his mic.
Okay.
So he has posted his question in the chat, so I read it. the same question that you क्या कहते हैं मतलब सर आपने जो समझाया था √10 minus x.
हाँ okay.
Sir, in that question, he is asking that what if we put x equals to 1, we are getting √9, okay? So if we take √9 out of the root, we get +3 and -3.
No, so that's why that's
Yeah, yes, sir, that's a doubt. I explained in the same way that you explained, but he is asking that way.
Okay, so what is that? You are saying, yeah, okay, just a
Sir,
minute. You are saying
he's putting the value of x in that under root.
okay, no issues. Yes, okay. If he's saying in place of x, he's putting 1.
Yeah, yes, sir.
So see that. So this is not you are getting plus and minus. See what is it? See, whenever you are getting the root right, outside of the root, this sign is there. Suppose this is only plus or only not sign, so you will consider only plus. If it is there written like this minus, then you will consider only minus. See, if you see that they are not written plus minus both, only one sign is there, only plus sign is there. Right?
Yeah, yes, sir. Yes, sir.
Just explain if we are not getting this, okay?
Sir, I told her this way, but he was just saying that ask him.
No. So that's the thing is here. Okay.
Yeah.
If it is before square root, always if you see that outside of the square root, plus minus is there. If it no sign is there, you will assume only plus, right?
Okay. Sir, thank you.
The answer for this question is x1 is equals to x2, right?
Sorry, who is asking?
Sir, it's the same question.
In this question?
Yeah, sir. Sir, the √10 minus 1.
Okay.
Output would be x1 is equals to x2, like you explained. After taking -1 and minus.
Yes.
-1 and 1.
Yes. No, not -1, 1. I just saying that whenever you have a square root, out beside the square root, if it is sign is written like this, then you will consider you are getting plus and minus both. If you are not written here anything, it means your plus sign is there only. Okay. Clear? If it is minus written sign is there, then your whatever you will take root here with the minus, it will be only. Okay.
Yes, sir.
Don't confuse with that. So if you remember that whenever is square root there, beside the square root, plus minus always should be written. Not after doing the square root, then plus minus. Okay.
So it is actually considered one answer, right? It is one output.
Yes. Okay. Next is Krishan Singh. Yes, Krishan.
Sir, my question is from activity 1.10, question number 7.
Activity 1.10. Okay, question number 7.
Yes, sir.
Okay, so in this question, asking for the possible cardinality of R. Okay, we don't. Okay, mute everyone yourself. Okay. So this P is a subset of, we don't have set, okay, but something information is given. Oh, sorry, yes, here is, yes, sorry, yes is here. This number of, please, somebody is there because his noise is like his voice, some background noise is there because of him. It's too much. Okay. What is that? See, you have yes, some element. So asking for when you remove S cross S, when you subtract from S cross S to R, what is going to be the partial and partial cardinality?
Yes, sir.
So from your side, is noise is coming?
No, sir.
Please. See, if this will happen, I'm not going to see. I am already. It's going to be 10:36. So if this will happen, I will close the session now. Okay. Okay. So please don't do this. Otherwise, it's already for me. It's going to be 3 hours and 30 minutes. I'm already tired. But try to finish your doubt. If this will happen, I will close your doubt. I will close the session. If you want, if anybody wants to close the session, I don't have any problem. I'm just closed because I have done 2 hour session, more than 2 hours.
Can I ask a question? Hello.
Yes. Let me finish his doubt, then your turn.
My
Just raise
question
your.
is from activity question 1.11, question number 2.
Just a minute. Let me finish her doubt. Let me finish her doubt. Let me finish his doubt. Some what is that? Him is there, not her. What is that?
Activity
Kishan.
question number 1.11.
Kishan.
Yes, sir.
So see, when you subtract, what you will get here from S cross S to R? What is going to be S cross S? Cardinality of S cross S?
Elements which are not present in R.
So okay, so what is going to be cardinality of S cross S? What is going to be cardinality of that set, Cartesian product?
4
transpose, right? 16. And from 16 you will subtract here this R. What is going to be cardinality of R? This is going to be 12, right?
Yes, sir.
And from this 12, which contain 12 element, okay, is any subset. So any subset means what? It could be 0, it could be 1, contain which element, no empty set, it could be contain only one element, it could be only two elements, right? This could be possible to sell to possible subsets, right?
Yes, sir.
So that's why now you choose your option accordingly. Okay.
Okay, sir.
Is it clear?
Yes, sir.
Okay, I think after Sanskar Saurav.
Hello, sir.
Yes, Sanskar, yes.
Yes, sir. Hi, sir.
Yeah, what's your doubt?
Sir, I have a doubt in
1.8
activity question 1.8,
question number 5.
question number 5.
1.8 question number 5.
Yes, sir.
Same doubt, sir.
Okay. 1.8 question number 5. Okay, in this question, asking for which of the following will be R. R is saying A is brother of B. So what's your, why is the confusion?
Sir, I am not getting understand in the last line, sir. In the relation set, it is the set builder form sentence, sir. I am not understanding. Please illustrate this.
It is saying A is brother of B, that's all. A is related to B means A is brother of B. This is the mean.
Sir, according to the question, my answer is option number 1, but it shows the correct option is option number 4.
No, is that clear, Sanskar?
Yes, sir, I'm clear.
Only it is saying B is actually a set and C is G is another set, but yeah, the relation is only A is brother of B. A is related to B means A is brother of B. Now check with that who is going to be brother of the another one. Okay.
Okay, sir.
Okay, next is after Sanskar, Raj is there. Yes, Raj.
Sir,
Raj is cannot unmute.
Sir, in this question, I have answered out, sir.
In the same question.
My answer is option number 1.
In the same question.
Yes, sir.
Why you are getting option 1?
Sir, according to question, sir, Ramu is brother of Neha and Anil is brother of Kirti and Suraj is brother of Neha and Kirti both. But according to the answer given, sir, there are too much options, sir.
So only I think it's missing Anil and Neha. Anil and Neha. Anil is here, okay. And what is the Anil is brother of Kirti, and this G is collection of sisters, I think, girls. No, G is collection of. Okay, what is our another thing is Anil is brother of Kirti, and I think Kirti is sister of. No, Ramu is brother of Neha. Anil is brother of Kirti. Surar is brother of Neha, and Kirti. See that what is happening. This information is given. Suraj is brother of Neha and Kirti. What it means that Neha and Kirti are sister, right?
Yes, sir.
So what it means that Neha and Kirti are sisters. So what is that? Here is Anil is brother of Kirti. What it means that Anil is going to brother of Neha also, right? And even the brother of Suraj.
Yes,
also. So now you can check what is the issue. Anil, only the extra element is there. Anil and Neha in this set is not there. That's why. But it's still in this set is going to be clear.
But sir, Anil is only brother of Kirti.
Where is man? Anil is brother of Kirti, but here is see that Neha and Kirti are sister, right? Because of brother, Suraj is brother of Neha and Kirti. Why you are confused? I am saying, okay, you have two sister and you are two brother. Okay, I am saying the whatever
Okay.
your brother, right? I am saying, suppose same. So Suraj is your brother. Just for sorry for that. Okay,
Hello,
I am saying.
Okay, sir.
Is it clear? If you check with your the different brother, still Neha and Kirti is going to be your brother, right? Sorry, your sister, right? So this is happening. The same scenario is happening.
Okay, sir.
I'm think going. I'm going to the last. Okay. Which is I think Aman Prajapati. Yeah. Hi, Aman.
Hello, sir.
Yes. What's your doubt?
Sir, I have a doubt in graded assignment.
So we are not going to discuss graded assignment.
Sir,
We
just
are not
to check that the question is correct or not.
No, question is correct. So don't worry. Question is correct.
Okay,
Hello, sir.
So don't worry. Question is correct. If you are getting the question, that's all. We are not going to discuss or even hint of the question also. The question is correct.
Okay, sir.
Yeah.
Hello.
I think yeah, Raj.
Yeah, sorry for that answer. Actually, I have one doubt. I'm not able to understand the lecture 9 like functions. Okay, like there's three topic: injective, surjective, and bijective. Can you explain
Yes.
it and with a real example?
Okay, so my suggestion is I think you are late. When we are discussing, I spent it at least for 30 hours. Can you rewatch again the session on YouTube? See that I have already discussed. Let me show you. In the end of approx 10:30, it will be tagged also. See that I spent it much time on injective subjectivity. Okay. So I suggesting you please rewatch and then again if you have doubt, come to the next instructor session. He will surely discuss.
Okay. Thank you.
Supriyo, what's your doubt?
Good morning, sir.
Yeah, good morning.
I don't have a doubt from this assignment per se. I just had a simple question. Here, Professor Mukund has discussed that natural numbers should be considered to be starting from 0.
Yes.
Whereas, whereas in India, in all the textbooks, including NCERT, they take natural number from 1 and whole number from 0.
So for the time being, for this course, for even for the maths one, you can consider it is started from 0. This is a convention for the time being for this maths one course. From the next courses, maybe you will not.
Accept this, sir.
So you see in the questions, it will be very much clear that when you will consider that 0 is going to be start or from 1. Okay, from 0 or from 1. Okay, so don't worry.
Okay, sir. Thank you.
So I think I have already solved with A823. I don't know what is his name. I
Sir,
think,
my name is Chetan.
yeah, Chetan.
Yeah, so I have a doubt. It's a question related to surjective functions. The question is the number of surjective functions from A to B, where A is 1, 2, 3, 4, and B is A, B.
Okay, just a minute. A is 1, 2, 3, 4. Okay.
And B is A and B.
A and B. Okay. So number of
what is the
surjective
number
function.
of surjective function from A to B?
Yeah, so actually there is a formula. Okay, for this formula, see there is a process also. This depend on the combinatorics or something is there. Factorial, permutation combination. This is a kind of combination, permutation combination. When you study, I think maths 2, you will very much clear with these terms. What is permutation and combination?
I've already done maths 1. Stats 1. I've already done stats 1. I am familiar with permutation.
I think that's why I'm saying in the stat 2. Sorry, stat 2 you will get. I think. So you are very much clear with this permutation and combination.
Yes, sir. It's in stats 1.
Okay, so you know there is a formula for writing. Can you search once how the number of surjective functions?
Just a second, sir. Just a second.
Yeah, if you Google that, you will find there is a formula with the permutation sign or factorial sign.
Okay, so I
With the
just have
number of
to directly use the formula for these type
yes,
of
you can
questions.
directly use or you can see there is one process, no, that for the find of number of surjective A's M and B's N. Okay, so I think I'm not remember this formula, but it's used the this. So derivation of this formula, I have to check it. Otherwise, directly you can use the formula.
Sure, sir. Sure.
Okay.
Thank you, sir.
For the derivation of that formula, maybe in the next session when I will take, I will very much, maybe I will tell you that how it will derive, but this time I'm not sure how it will derive.
Sure, no issues. I understand.
Okay, this is all about. Thank you so much for joining. I'm now
Sir,
closing the session. Yeah.
sir, I have a small non-academic question. Sir, I gave qualifiers last year and I have registered for Meetum right now. Sir, I have signed in with my student ID provided by IITM on Zoom. Sir, my display name is Shirish Pandey, but it's showing some A161. Is it my roll number or something like that?
Where it is showing?
Sir, clearly you can see my display name is A1.
No, so you have edited,
A161.
you have opened with your this name, okay?
No, sir.
So it's
In the
happening to
settings,
everyone who's joining with
Yes.
student ID.
Is it the
So
roll
maybe
number?
because of that, I'm not sure. Yeah, maybe it is showing that no issues, but no issues. I think so. I'm not sure, but yeah, if it is for all of you, it's showing. Then I think because of that, it's happening. Or either see, it is a Zoom, no? So you can edit your name on the setting of Zoom. Okay. Yeah, you can say do the setting. You can change your name. So I don't think it is a problem. It is by default name it is giving for your email ID, but you can change your name.
So in
Okay.
the settings, it shows the correct name. It just only during the meeting, it shows some A characters instead of the name.
No, it is from your side. I'm not sure, but still, I think when you are joining it, maybe when you switch your account, it will be reflect to your mail ID with your institute mail ID. Because of that, it is happening. Otherwise, I don't think it will happen. See, when I am also, I have edited this. See, I feel I have already faced this issue. I changed, and see, switching of the Gmail also may happen. Okay, so check with that. Okay. So,
Thank you, sir.
yeah, thank you so much for joining. Have a
Can
good
I
day
go
to
for
all
the
of you.
last question if you are have time, sir? Sorry, I am late.
No, so first I will say I am in hurry also now. It's
Okay,
almost
okay, sir.
11. So this is 4 hour session it went. So
Okay.
I have meeting also. So thank you so much. You can ask your
Thank you.
doubt in the TA session. Okay. Thank you so much. Have a good
Thank
day
you,
to all
sir.
of you.
Thank you, sir.